opportunity. So this is the anatomy of our ANAV. The main processor comes here is the GPU, which controls all the high level and sends the low level signal to PICSOC microcontroller over here, flight controller. We have used a 3D printed chassis combined with carbon fiber rods for more sturdiness. The chassis is of X shape for better stability and maintaining the CG in center. Here comes an optical flow sensor for better localization. And we have used a stereo camera for visual inertial odometry and finding the safe spot in the arena. Then we have a novel landing gears over here, which are quite suspension, which resist the surface when any damping is there. Yeah. Next slide. About the chassis, we have 3D printed the middle and top part in ABS material for better stability and strength. And also, we have considered the heating of processor. So, considering that heating, we have designed this chassis and used ABS material for this. And the chassis shape is X shape. The total weight of our ANAV is 1700 grams. And dimensions are 54 by 54 by 24 centimeters. Next. And the main sensors we have used for localization are optical flow sensor, which gives us relative motion along X and Y. Then a depth camera, which gives us point cloud data. And we have also used the visual inertial odometry from depth camera, which is helpful for estimating the points in arena or estimating the safe coordinates with respect to X and Y. And the IMU is placed in flight controller for roll, pitch, and yaw. Next. Now I would like to call one of my teammates for briefly telling the algorithm of scanning and autonomous navigation in the environment.
Shivam, some of the team members can start setting it up if they are ready. Okay.
So what sets our algorithm apart from the other algorithms, and this is something which I like to say a lot, is that our algorithm is not constrained to any type of arena. We have tested it in indoor arenas, outdoor arenas, with boulders, cardboard boxes, and many other type of obstacles. And it shows good results. So for input data, we are taking point cloud data, which is basically XYZ coordinates of all the points in the map, and we take in arena dimensions so that if any area outside the arena is visible, it does not detect a safe spot over there. Now when we get this point cloud data, we form a grid of X and Y, and elevation of each 8 by 8 centimeter grid is plotted in each cell. So for every 8 centimeter of X and Y, the mean elevation is plotted. Next, now we usually expect that we'll get elevation values all over this grid, but this is not often the case. Sometimes we get NaN values. In fact, 40% of our elevation data consists of NaN values. So how do we deal with that? We are implementing interpolation. For interpolation, now we need to detect two types of safe spots. One is flat and the other is slopey safe spots. For flat safe spots, we first take in the elevation grid and we perform radial basis interpolation on it. And for slope safe spots, there is the same grid and we perform nearest neighbor interpolation. Now why two types of interpolation for, two safe spots? It's basically, the primary reason is that it becomes much easier to differentiate between slope safe spots and flat safe spots. And the second reason is that when you think of flat safe spots, if you are implementing nearest neighbor interpolation in flat safe spots, let's say you get a lot of NaN values at the boundary because it's flat all over, but then at the boundary you have a lot of NaN values. So it will take the value of nearest neighbor. So it expands the safe spot from its original shape. So that's why we avoid using nearest neighbor interpolation for flat safe spots. And for slope safe spots, we are using nearest neighbor because it gives kind of a gradient. So when we get a gradient kind of, then it becomes easier to detect slopey safe spots. I'd like to call my teammate who's been working on this.
For flat safe spots, we are using cost-based method. In that, we took 3 by 3 cells and took mean elevation of all of them, and then compare with to the our main elevation cell. Then for a slope safe spot, we take XYZ coordinates and form 7 by 7 grid cells and try to fit plane on it, and then by using plane equation we found its slope, and we know the slope of our 15-degree slope, so we just compare it with it, and that's how we detect slope safe spot and flat safe spot.
Okay, Shivam, is it ready? Your team is ready for actual?
Yes, sir, we are ready. Just we are configuring the Wi-Fi, then we will start in 2 minutes.
Okay, fine, good.
Hello. Then we merge our safe spots. We are continuously detecting every safe spot, and according to the areas, we are merging it. And to avoid its home position, we do not detect any safe spot around our home position in 50 centimeter radius. That's how we avoid our all safe spot in our home position. Then for safe spot coordinate, we are finding longest Euclidean distance from our binary mask. We are making binary mask of ones and zeros. Zeros are our ones are our safe spots and zeros are our non-safe spots. Then we are finding that one number which have longest Euclidean distance from zero, and then that will be our center coordinate of our safe spot. Next. For next, I would like to call my colleague Neha.
So there's one novelty in our algorithm. It is rescanning. So basically, after we have moved throughout the arena, what happens is drift gets accumulated in the sensors. So there's often a drift in localization. So even if you have got the right safe spot coordinates, you often end up landing somewhere else due to the drift. So that's why we have implemented rescanning. For rescanning, what we do is, once the drone has reached the predicted safe spot coordinate, it again finds the centroid of the safe spot located below, and it compares the centroid of that safe spot with its current position, and the difference in it is equal to the drift accumulated, which it then covers, and then after that it is able to land on a safe spot. So this was all about our safe spot algorithm, and okay, so thank you so much.
Ready? So we are ready now. We will initiate with the telemetry and taking off of the drone.
Yeah,
so
you are going to, you can tell, you are going to first demonstrate autonomous or whatever. What is the plan?
We are going to demonstrate completely autonomous.
Okay, fine.
If in case drone tries to goes in the net, we will shift it in manual mode and we will avoid the any mishaps.
That.
Yes, definitely.
You also the activities you just briefly explain.
Yeah, lighting is okay. Yes. So I will briefly explain the algorithm flow. Now drone will take off from home position. After taking off of the home position, it will reach the height of 2.5 meters. Then it will go in front direction. If it detects the yellow border, again it will go in back direction for detecting the end of yellow border in X direction. Similarly, it will come to the home position again and it will go in Y direction. So from this, we are getting the dimensions of arena. This logic this logic can be helpful for any size of arena. Battery supports around 9.15 seconds and minutes, sorry. Then after that, after scanning the dimensions of arena, we will put some preset points based on the dimensions of arena, and drone will start scanning going to that preset points of the total dimension of arena. While scanning, it will store the point cloud data and identify the best 3 safe spots in the arena. So now drone has started, setup has completed. My colleague Hitesh will explain you the further process.
Yeah, I will guide you all guys along the run. Sir, are you able to? Yes, the drone has started and it will achieve a height of 2 meters. As Shivam explained, the first part of our algorithm is the drone will perform yellow line detection and it will localize itself inside the arena. For the main motto of this doing this is to judge the robot should know the entire size of the arena so that it can divide the arena into grids and perform safe spot detection. Hello? Okay. Yeah. We have done manual intervention. We'll start again. We'll start again in autonomous mode. Okay.
What was the issue exactly? Now, while detecting the border along x-axis, it went little bit toward the y-axis, but we wanted it to go through the end of x-axis. So, because of some little drift, it went to that side and detected the y-axis border. So we are starting once again for detection.
We are resetting the connection right now again, and we'll continue in autonomous mode again.
In light configuration, if you want, you can ask for.
If we can close the lamps on that side. Also, one light from this side maybe. Hey, above is okay. This side light, sir. Above is okay. Above is okay. We can just switch off from this side. Yes, sir, all okay. Yeah, it's not reflecting on this side. Yes, sir, they are okay. It's okay. Yeah.
So here we were changing now. Previously it was scanning along x-axis first, and then in the y-axis. Now we are shifting it to scan along y-axis first, and then it will scan for x-axis. So that issue will not occur once again. So reason behind doing that is it went to the y-axis while it was supposed to go to x-axis because of little drift, and it detected the y-axis first. So we are first scanning the y-axis, and then we will go to x-axis.
No, sir. Actually, what we are doing in this part of algorithm is we are mapping the size of arena so that the robot should know the approx size. So what we have done is, as the robot should not go the outside the yellow boundary. So what we are doing is by maintaining a distance such that it will also detect the points which that is the safe spots inside the arena, as well as it will maintain a safe distance from yellow line. That's why we are changing it. Yeah, if you are okay, we can go ahead. Yeah, all good. We are trying to establish connection with the flight controller. When we are done, we can move ahead.
Yeah. Shivam, is there any issue?
Yes, the processor is not able to connect with the flight controller. So
Okay.
whenever it establishes the connection, we can go ahead. Just 2 minutes more.
Okay. If you need a different scan, you can reorient and start. You need not change the update the code and all. Okay.
Yes, actually the connection we are checking right now. We have established the connection, we can move ahead. Yeah. We can start when the base station is ready. On the telemetry side, Devyani, move up the laptop screen. Wait. Okay, done now. So in the image view, we can see the SLAM algorithm working, that is VSLAM. Over here we can see the XYZ orientation along XYZ axis. Over here we can see the battery low and lost link. And here we can see the velocities in XYZ axis. And whenever the robot is able to detect or land on safe coordinates, it will it will be displayed over here. As the first safe spot will be here, second here, third here. Yes, sir. It's booting up. Devansh. Okay. We are ready to start. The robot has reached the height of 2.5 meters and it will start detection of arena size using the left side, left yellow side. We are doing manual intervention and we'll start again.
Shivam, is any issue again?
Yeah.
Was there an issue? Sorry? Was there any issue why it had to be, because it was detecting the periphery, no, properly?
Yes, sir, it was detecting the periphery,
Yeah.
but there is some issue we are targeting, then we'll reboot again.
Okay, if you find some other place, some other orientation, if you want to
Okay.
start from there, if it helps, go
Okay.
ahead with that.
Okay.
quickly, huh? Without any change in the.
No, sir, we have an algorithm such that it will never find a safe spot on the yellow line or beyond the yellow line.
Oh, it was showing like that. It's just-
Sir, that was the HSV values to detect the yellow line.
No, what I suggest, no, you don't do any reconfiguration. You try
Okay.
to head from this direction.
Okay.
Okay. You start from.
Yeah. We have started. We have done manual intervention and emergency safe landing.
Okay. Okay. My suggestion is, if you want to start from different orientation, you go ahead.
Yeah, okay.
Goes this direction, if it is okay. Just. You need not change any code or anything, because you have another 10-15 minutes time. Okay. You start from different orientation.
We can, if we can just shift in the over another place or
Yeah,
just
whether
a little bit
orientation,
inside.
orientation you want other direction, let it go. It's not possible. Or position.
Position to be shifted.
Okay, you tell, no issue. Which
Okay.
is comfortable?
Which will be the ideal position for us?
Is
So
that okay?
near
Where
the
you want to
center,
shift?
can we do?
Where?
Near
Little
the
bit is
center?
okay. But you should be able to do it actually.
Yeah, yeah, sir.
Come, just. Okay, let us see.
Sir, if this is fine.
Oh, okay, we got, yeah.
Yeah?
Got, yes.
Okay.
We'll see. You have any semi-autonomous mode or something where you can manually?
Yes, sir. If we start in 2 minutes, we will still have time to cover the entire. So if I decide that if we didn't get the time, we'll switch to manual and detect.
Manual, at least you show this,
Okay.
whether you are able to identify the safe spots.
Yes, sir.
Okay, that is
Yeah.
a good attempt.
Yes, sir.
First
Yeah.
to do whatever you plan, then
Yeah, yeah.
go for manual and show what is there.
Yeah, yeah, yeah. Yes, sir. Yes, sir. Yeah, we have started again. Yeah, wait. Yeah, the algorithms is working right now.
So currently it is scanning along y-axis. So it is checking the maximum y-axis.
Now we saw that it reached the maximum value it can attain, and it went back. Now it will divide the attained y value by 2 and get into midpoint, and after that it will start moving along the x-axis. Yeah, this point is the center of the y-axis. Now it will start moving in the x-axis to gain the knowledge about x-axis. Yeah. It will move toward maximum x coordinate it can attain in that direction and revert back from that. Yeah, that's the stop point. It will revert back and come on this side again. This flow was just to gain the entire measurements of the arena. Now the next part of algorithm will be to again put set points in the arena. This robot will autonomously put set points according the dimension it has got. And now it will move to the center and move on the set points to scan for the safe spots.
So based on the maximum x and y, it has determined the arena dimension, and it will distribute equal points in the arena, preset points in the arena based on the maximum perimeter of arena, and it will go to that preset points for scanning. So with this technique, we cover the whole arena.
Now the halt is for, we are launching our next algorithms as explained for safe spot detection. That was NN and radius based. Also it has activated the rescan algorithm. Now in the deduce perimeter, the robot has given some set points. It will reach that set points and scan for the safe spots. Firstly, it will scan the entire set points. Then after that, it will go for the safe spots. It is now currently scanning the entire arena as the set points. It is taking all the data, topographic data of the arena, and after gathering the entire data of arena, it will fit the safe spots accordingly. Okay. The set points is done. Now the robot will move toward the safe point. As we can see, the robot is moving towards the safe space over there. Now it will perform rescanning. Rescanning is that the robot has moved the entire arena. That's why the drift accumulation has been done. To eliminate that drift accumulation, we have induced the rescanning algorithm. Yeah, it's rescanning, and as soon as it gets the safe spot in the drone's POV, it will move to land. Array. Let it go, Rishikesh. Let it go.
Yeah.
It tried to land on this safe spot, sir.
Okay. Okay. It had identified some safe spot.
Yes, sir. It had identified some safe spot.
Okay. Okay.
Yes, sir. We can see the coordinate of the first XY safe spot. Now it is moving ahead to another safe spot. It is heading towards the 15-degree slope safe spot. Now it has started rescanning. Once the robot is able to confirm that the safe spot is underneath it, it will begin landing.
Shivam, some battery low, is it happening? You just check also.
Yeah, sir. I think we would be able to do this landing as well. Yeah, okay. There's a drift in. Sir, there's a battery change.
Shivam?
We'll try to attempt the. Okay. So, we'll try to attempt the third safe spot as well. We can see the safe spot coordinates of the second safe spot over here. It's in rescan algorithm right now. Yes, it will get it when it finishes rescan. Yeah, we got the third safe spot.
Good, Shivam. It identified 3 spots, even though it is not exact.
Yes, sir.
And then try to land. But there was no manual intervention, correct?
No, sir. No manual intervention at all. Sir,
Okay.
if we can do a manual one round, we can show more accurate.
So we don't have time at all, actually.
So finally, after detecting 3 safe spots, it will try to go to home position again. So what we are seeing right now is because
Is it in the same auto run? It's continuing now? It
Yes.
go to home position now?
Yes.
Okay, let
So
us see that.
right now, what we saw was because of drift. It increased iteratively. That's why drone was shifted little bit along X and Y axis. But this can be covered if sensors are recalibrated and yeah.
And now home where it has identified, it has to go back to home, no?
Yes, it is again scanning for the home. It is confirming the home. So after reaching every safe spot, it rescans that safe spot, whether it is the exact safe spot or not. So after rescanning, it confirms that this is the safe spot and then tries to land on that particular safe spot. So we have used a 2-step authentication technique where we are confirming the safe spot with the help of rescanning particular area.
Okay, allow it, Noish. Okay, this was a home back landing, is
Yes.
it? Okay, very good, very good.
Thank you.
Shivam, I understand, okay, except for the drift and some identification errors is okay. It's a good performance.
Thank
Good.
you, sir.
Good, nice. Nice, thank you. And you have any that safety demonstration? If it is okay, it's okay. Otherwise, we'll go ahead with it.
Safety demonstration.
If battery failure, whether it will come down automatically or that's
So
built in?
battery failure we can demonstrate, but currently
it's okay, no
battery is
issue.
okay. Battery is not completely low.
Okay. Okay, Shivam, it's good.
We have to modify the code accordingly. Then. 10 minutes.
Okay, okay Shivam. It's sorry?
So if you want to change check the battery, so we can change the threshold. Now it was around 10 volts, so we can increase the threshold and we can detect check the loss. But it
Okay,
will
it's fine. It's a good. Okay. Okay, we'll close this now.
Thank you, sir.
Okay,
Thank
okay,
you all.
thank you. Very good. So we can. It's okay. No matter. That's all. We can ask the next team.
I hope we would able to demonstrate all the safe spot and successful landings.
Yeah, it's good.
The only thing was was because of little drift. So we can correct it with some sensor calibration.
You had not planned to update any sensor, or drift was higher slightly. So how the different spot was helping slightly better, that also you can tell. So initially it was having a little more issue. See, other spot to this spot, how it has helped to overcome the issues. Okay. No, the initial spot, it was going in other direction.
Yes.
Or we should have allowed more time, or what you feel? Why it has, changes made some difference?
So firstly, means when we started, it was taking some lights. That's why it was reflecting and not going to the desired direction. So we changed the axis first, and because of that, we were able to do the all scanning. And based on that, we mentioned the pre-feed safe spots, and it was accordingly going to that and landing.
Vertical flow camera, what are you telling? Updating is not done, we can tell you. It is simply that because of drift it is halting around.
Yes.
No update has been taken.
Sir, sensor update is taken. Yeah, sir, that issue. Sir, we identified some preset points. So it was going to that preset points, but because of drift, it was looking like it was circling in the arena. That can be done by recalibration of sensors. In that specific area, once it came down because of some power fluctuation, and again it regained the power. So we were charging the batteries continuously late night. That's why many cycles happened, and this cycle was a little bit hampered because of that. Yes.
Hello. Hello.
No. This battery was charged after every cycle. Yeah. Power fluctuation was there. Complete power was not lost over here. So it regained again. Thank you.
Hello, one question here. Hello.
Yes, sir.
See, there was an attempt to land near the safe spot, but it's almost was slightly the offset. Then it took off automatically. Was it manual which was taken off?
No. After that takeoff was completely autonomous.
Okay, means you could come and detect it is not flat at the very frag end and then took off. Is that how is that actually happened?
No, it initiated for next safe spot. If that was not correct, then it initiated for the next safe spot.
Okay.
That's why it took off.
I have one more question. You said you validated algorithm for the different obstacle conditions like box, cut and box, rock. What challenges you faced during those things?
So for let's say the boxes all have a flat area, means the top surface is a bit wider. So the elevation values that we get through the point cloud, they are sharp, they are steep. So it can be easily classified. Whereas in this stone-like structures, they have a slope. What can I say? A hump-like structure. Yeah. So it's not sharp, steep slopes. So that's what we faced a little problem in there.
So what change you carried out to sort out these issues?
So we interpolated the mean values, and if you want in more detail, I can call upon the one who did it.
Yeah, we would like to hear.
Currently, interpolation was different as we tested on our arena, but our arena was dense arena. This was sparse arena. So for this, we can change the interpolation. So with that, we can solve this issue.
Correct. So whenever you do some visual algorithm, that purely depends on the feature of the object, the light intensity and all those things. So those things only you will trim, right, your algorithm. So that way
Only
when you go for the different object, you may have to retune the differently.
No, only for the yellow line detection. As for this specific arena, we were using some computer vision algorithms. But for scanning, there was a different technique which doesn't hamper the lighting conditions and all. Means we can do that testing anytime in the daylight.
And you are used the boundary as your reference to calibrate your sensor, but still you landed in a lot of errors.
We used
What
boundary
could be the
for,
cause of for that?
we use the boundary for calibrating, for identifying the exact dimensions of arena. Now, if we change the arena also, still the algorithm will work and still it will find the safe spot in any dimension of the arena. That was for identifying the maximum borders or maximum area of the arena. So
No,
based
the
on
question was, see, even you identified the boundary and you calibrated and you have seen the safe spot scan. What was the reason for the offset where you try to land was not exactly, why, what is the reason for error?
So the reason for scanning the boundary was to efficiently scan the entire arena with the least minimal path. So that was what it was doing. We know the camera FOV is around 4 meters. So we calculated that offset so that I can travel the maximum arena in using the shortest battery usage. So the drift that was that had happened was because of the optical flow sensor that we had used. So it had some miscalibrations today. So that was the reason.
Anyway, it was good comeback after the 3 attempt.
Thank you, ma'am. Thank you.
Avionics, no? Team Avionics. So, any one member is that? Team Avionics, who is the person? Ah, yeah. You are ready? Other people are ready? Okay. See, other team can start setting it up. Okay. So, they have selected already a point towards north and he wants towards south. Okay, go ahead with that, no issue. And I think you know the competition requirements. From the home point, you have to search for the 3 safe spots and land and get back to that. Okay, and your periphery is marked by yellow, and you are given three attempts to do that. And today, as we told, there is a time constraint is there, so try to complete quickly. And then you have preferences to do a fully autonomous right from the word go and complete. And in case you want to intervene manually, you inform and go ahead with the manual intervention. What you have done, you have to tell. In case of any requirement of elimination and other things, you address now itself. Okay, you take care and go ahead. If you are ready, you can go ahead with the actual operation. And if you want to briefly explain the system, you can just.
So just a second.
Yeah. Sir.
So can you just please? Thank you so much. Okay, so first of all, very good morning to all the jury members and everyone. So we are Team Avionics from Charusat University, Gujarat, and today we are going to demonstrate the performance of ANAV Kalam. We have named our ANAV Kalam, and this is our prototype that we first initiate during the initials round. And due to the same some change of configurations and as per the jury's suggestion during the elimination round, we decided to carry on the frame that on which we are testing. And yeah, if you'd like to show us, and this is the working of our prototype.
Nice. Okay. And this prototype, how?
Sorry, sir. Okay.
This was made by yourself?
Yes, sir. So, okay, I will quickly brief the. Okay. Yeah. So first, the ANAV will take off at the altitude of 2 meter. And it will do a square pattern. And after completing the square pattern, it will scan the whole arena. And it will return to the home position again autonomously. And then it will analyze the whole map. It will identify all the safe spots. And it will then again take off. And then it will land one by one.
In case you have any difficulty in identifying going, you just manually have to show that it is able to identify autonomously safe spots. Okay?
Surely, sir.
You can do that. That decision you can take. But first attempt the autonomous quickly. Okay.
Yeah,
Right.
surely, sir. Thank you.
Oh, this was done by your own design, is it? Oh, it's a good thing.
We have used before, but we were testing. Yes, sir, it's fine. Landing the machines. Okay, so currently we are setting a virtual home position, and we are using no GPS. It's just a virtual location for the home position. Just 2 minutes. Actually, we have to reboot the system.
Sir, they wanted to show localization and mapping on the screen. So both the laptops they wanted to display in front of the camera. So they are setting up for that.
Okay, so the mapping is initialized. The drone will take off in 10 seconds.
So what is that mapping you told?
So we are using a visual SLAM algorithm for the mapping, and we are. Yes. Sir.
You just announced the activity.
It's on.
Dharmil, you announced, is it the autonomous operation?
Okay, so drone will now go forward and it will have a square pattern along the edges, and then it will land to the home position. I'm sorry, we are having issue.
Any illumination adjustment is required, you can tell to us. Any change in light condition is required, you can let
No,
us.
no, no, no. Actually, we are facing a fail-safe issue. Just give us a few minutes.
Dharmil, can you explain once again?
Just okay. So the thing is that drone is not able to get the launch position. So because of that, the fail-safe was occurred, and the drone was not moving.
Okay, what you want to do now?
Just we will figure out just a few minutes, and we will figure out.
Okay, you take 5 minutes to see. Otherwise, you can manually scan and show that if your safe position is getting detected.
Yes.
Okay.
So we will like to we'll try for one more try. Yeah. लॉन्च कर दीजिए प्रवाद. So the drone has takeoff. Okay, so now the drone is moving forward. Now it will change its heading. It will move towards. It will change alignment.
Did it detect any safe spots? What was your observation?
No, sir. We are doing post-processing of the map.
Okay, it did not complete scan. So if you feel autonomously it has a problem, manually you go around and get the scan. Okay. No, yeah, if you have a scan. So we have another 20 minutes. Huh? Okay.
Switch off करो. So we have the battery is low. We can switch the battery in 5 minutes, and we can do the manual scan, and we can show you the safe spot identification if that's fine. Thank you.
Okay, you will do a manual scan and show in
yes.
your algorithm. So we'll try to. Okay. So the identification will show in this screen. Yeah. What is being displayed here? This. Okay, right. This. Oh, that. Yeah, yeah. And then we will show you the identification. Yeah, yeah, you show that. Yeah.
you are left with 10 minutes.
As you can see the map on the screen that we have available with the telemetry and the mapping available. We'll be taking off using Mavroxy. And the localization will be done autonomously. That is not something that we are doing manually as of right now.
We have to slightly make like this. Fine? Fine. Is it okay? Okay.
We are arming the drone as of right now, and it's in takeoff mode.
You can tell autonomous or?
You are doing manually or?
Autonomous, manual.
The localization is being done autonomously only. It is moving forward 9 meters as of right now. It would now turn over. It is going to move forward along the edges. It is mapping the entire position mapping as of right now. The map is being generated, as you can see on the screen over here. It is being generated as of right now. And along with that, it is also showing the path that the drone is following as of right now, as you can see on the screen.
So, sir, manual commands are being given for scanning.
It will now be returning to its home position.
Okay. The scanning is complete?
Yes, sir. The scanning is done as it landed on the home spot.
Okay.
Download the map on my laptop, and or if you want, we can show you the visualization from the onboard processor as well, but it would have some delay. So I will just download the map and do the processing on board. Is that fine?
You will...
just let me come there for a second. Yeah.
Yeah. You just start showing that.
Okay. First, I will show you the 3D point cloud that is being generated.
Okay.
That will be shown on my laptop, because the rendering would be over Wi-Fi would be a problem.
But you are accessing that computer and showing, or how do you?
I am actually accessing the Jetson from here.
Okay.
Yeah.
Okay. Good.
Yeah. It will take a few minutes.
Yeah. But they need some time. Other team we can start. You will, okay, good. Somebody should keep doing it. Shall we start the other team? Otherwise, to select. Your team is ready for? The team is ready? So you can select the spot and then. So you take another 5 minutes, no? So we are just preparing the next team. In the meanwhile, they will run the offline program. The next team is Team Rudra, is it? Team Rudra. Okay.
Hello, as you can see on the screen, I am right now connected to the drone, the Avionics at Ubuntu.
Just a minute, the team is, screen is not shown.
Is it visible now?
Just a minute, the camera has to be.
Yeah, now? Yeah, okay. Let me just get into the directory and
Just meanwhile, you can pick up the spot and the direction, just to pick up one spot from here. Just tell the number. 5 is this side, okay? Then it's okay for you? Any place? This side? Good. That side, down. And then heading direction. Yeah. You put it back. Right? So the next is north. North is this direction.
Sir, Team Rudra, NO weight is 1.45 kg. NO weight is 1.45 kg for Team Rudra.
yeah, so now as you can see on the screen, the analysis has been started on the onboard drone there. I am connected it to via SSH.
Blank certificates are there, no? They were not brought?
It will show the visualization just in a second. Drone cancel. There is some processing issue over the Wi-Fi. It's not directly showing. Just a second, it will show up.
So it may take some time.
Okay, yeah. So you can see the map on the screen. It's rendering.
Okay.
Okay, yeah. Okay. It correctly identified one slave spot.
Okay.
During the initial phase, it drifted a bit.
Which is the home point? Which is the home point here?
Home position is right here.
Okay. Okay.
And this is the two safe spot that it detected right now, analyzing the slope and all the data. Okay. And now I would be showing you the analysis of the drone. the analysis that it is doing on board. So it will show up in a second. Just let me start by explaining it. Okay, so first what we are creating is an, okay, one second, I will start it again. Okay. So as you can see, this is the map that is generated. It didn't render properly halfway through, but we have the whole map of the arena. The green line that you are seeing is the trajectory of the drone that we are getting from the SLAM algorithm that we are using, and it is being shown here. So when it went here, the drone was slightly turning left and right, as you have shown. So no worries. So as you saw the images, the drone was doing that, and yeah, X, Y, Z, all three are there. In our localization, we have all the data. X, Y, Z. Okay, this is yeah. These are the safe spots that we identified. Yeah. Okay. This one was identified.
Okay, this was identified as 2 spots, is it? Okay.
Yeah, it actually created 2 safe spots.
Okay, good. That's
Okay. Now the analysis will be shown here in a minute.
So what is the difference that and this?
This was the 3D map. Okay, this is the basic analysis. Can you zoom out the camera a bit? Yeah, thank you. Okay, so this is the slope map that we are generating from the point cloud. So what we are doing in our algorithm is we are generating a point cloud of the whole arena. Then we are processing it in after landing at the home spot. Yeah. This is the processing that you are seeing right now is done on board only. Yeah.
No,
not the map, the coordinates of the safe spot, and the map would be used for for it to localize itself again. So map is now generated and saved in the memory. It will be used again. If I go and start right now from the home position, I would have an option to start the localization mode, in which the drone would already know where it is in the arena, given any point, at any point. It would know it is at this point in the arena.
Okay. This map has been created and the memory is available.
Yeah.
Okay, fine.
I am just downloading the original DB file, the database file of the map on my laptop because the Wi-Fi rendering is slow, as you can see. Okay, so this is the slope map that was generated from the point cloud. The point cloud has X, Y, Z values. From the Z values, we create first the height map of the points. And then we take the derivative of the height map to get the gradient. And then we calculate the slope map, as you can see here. Okay, yeah.
Okay, now after this, if you have to do autonomously, what is the requirement will come? Will it?
Okay, no.
Will it use that?
The search area mask is this, and then it will mask the area properly. It would identify the heighted objects and set as obstacles.
Position 5.
And then we would go to possible safe spot center.
North. Okay.
Here it found
Position
many
5.
safe spot area. So it chose 2 optimal safe spot that it found to be more accurate.
Okay.
And we have made the adjustment that the overlapping safe spot don't come.
Okay, this has been already done by the onboard software.
Yeah, onboard software.
Okay, very good. Right. Good.
So,
that's good.
We have the coordinates of this safe spot. We can manually take it there and put the drone there and send it from there here.
Okay, manually anyway, it should be possible. You already demonstrated that.
We have the coordinates of the map.
Okay. This scanning was done autonomously, no?
No. In the initial, when we first started with our script, that was fully autonomous.
Okay.
It faced some issue in the post-processing part, or we don't know what happened.
No, only while landing some intervention was there.
Yeah.
Back to the home position. But initially the scanning was going.
Okay. It was given command
trajectory was given.
Trajectory was only given. The manually the localization and the stability of the flight was done on board using the sensor.
Okay.
Using the point cloud data and the odometry generated from the point cloud.
Okay, very good.
Yeah, we are planning to scan the. Yeah. And manual.
Manually trajectory.
And then what we did was, as you can see, when it landed, it would process all this data.
Right, okay.
And then it would give the coordinates of the safe spot, the 2 safe spots that it identified.
The exact coordinates has also been identified as numbers?
Yeah,
okay.
sir. Yeah, okay, so...
okay, display, turn it to.
So the 2 safe spots are right behind aside itself. This is the y coordinate and this is the x coordinate actually.
Why that minus 1.2 also is there?
No, that is due to the height, the algorithm that we are using.
Okay.
What I have done is, what we have done is that we evaluate the map above. So to because
is it with respect to home point, where it is finding actually?
Yeah.
With respect to home point.
Yeah, respect to home point. And there is a drift in our map.
Okay.
So because of the sensor, the camera is angled at a certain degree. So it captures the front view more rather than, so it is expanded a bit. So,
okay.
Here it calculates the average slope of the arena, safe spot area, the algorithm. So basically, if there is some kind of obstacle there which has a higher slope, then it would create, average it out and it would increase.
Okay, good. It's good work. It has almost found 2 spots in the safe spots in that required area. It's good. Very good.
Yeah.
Nice.
And if I will just check if I have the map, I can show you the 3D point cloud map.
Right.
That
That also you show sometime. Okay, go ahead, please. Okay, we will go with the next.
Yeah.
Okay, good. Thank you. Thanks. Okay, we'll go with the next team.
Sir, I have the map right now downloaded. If you want, I can show you right now. It would just take 2 minutes.
Meanwhile, Team Rudra, I think you are aware of the requirements. So you have identified the home point. From there, you have to go for scan about 2.5 meters and get the 3 safe spots and land and get back to the home position. And you are supposed to maintain within the yellow boundaries. Okay, and you can do autonomously fully, or in case you want to intervene and go for semi-autonomous. So the requirement is first, if you are able to demonstrate that you are able to safely identify autonomously also is good. Okay, that's a good thing. And in case any illumination required or heading required or any position required, now itself you can tell. Okay, it's fine. You want to plan everything autonomously? That's okay. Okay. So okay, fine. If you want to explain something.
So good morning, judges. Myself Anurag Shetty, team lead of Team Rudra. So we are from Ramravadik Institute of Technology, Navi Mumbai. We'll be presenting the demo of our drone RA1 Ravan. So the full form being Rudra in F1. So I'll just quickly explain you the process of how our task will follow through. So after takeoff, the odometry gets reset. So we want a fresh start at the beginning. Then the ANAV has to first detect the yellow borders. So firstly, it goes forward, then backward, then it comes back to the home position, hovers for a second, it doesn't land, just hovers. Then it goes to the right, and it goes to the left then. So in these 4 directions, we get the idea of the complete border. So for the yellow detection, what we are doing is, first there's a hue correction, then there's a color detection. Lastly, there's a contour-based detection to filter out the light from the yellow-based objects, which in case is the border. And in the end, we get the final detection of the complete border. So as the border is going to be detected in some parts, what will happen is, because of the contour detection one, the yellow border will be fixed. So parts will get fixed and there will be noise reduction. So due to that, we'll get a complete layout of the arena. So the ANAV knows that it doesn't have to step beyond those bounds. Meanwhile, what happens is when the drone takes off, simultaneously along with the odometry reset, the mapping also starts. So when the boundary detection is done, we have already mapped out a certain portion of the arena. Now, due to the border detection, we are using that data, so the corners of the arena we get. So using that, we are able to identify the unexplored regions now, the rest of the arena which was not mapped initially during the border task. Then we are mapping the rest of the arena. Once that is mapped, all the safe spots will be detected and the task will be carried out as it is instructed. It will land on each safe spot one by one, and the sequence is decided. It will land on each space one by one, then finally return back to the home position, fully autonomous. Okay? Yes, sir. Yes, I'll be no issue, sir. I'll do that. Yes, sir. Yes. Okay. Thank you. Yes, sir, we are initializing the task, starting now. Okay, so task is started. It will take off to a height of 3.5 meters. Beginning the boundary sequence.
For safety purpose, you can keep remote control in case you have to.
Yes, sir, we'll do that if needed.
You have.
Sir, we haven't. We'll do that. I'll let you know. Okay, so it has detected the right border. This is still fully autonomous. We haven't taken manual control anywhere till now. Okay, so identified this border as well. So the mapping has started. It is exploring the unexplored regions. Still fully autonomous. So we'll be manually landing it for now because I think it is getting stuck.
Manual control.
Yes, sir. Manually landing it. Border detection was complete, fully autonomous. We are landing it manually.
Anurag, can you explain what has happened?
So the border detection was working, but if you noticed, it actually stopped, didn't go to the full boundary. So there's some issue with the color. But after that detection, if you noticed, it did the full mapping. But so just we're having an issue with the safe spot service. It didn't identify any safe spots because it didn't fully map. So
No, did it identify any safe spot? Or?
No, sir. The full map wasn't made, right?
Okay, after map only it will do, full map, okay.
So, sir, the issue was that while it was going forward for the border detection, it didn't go fully. So, it hasn't gotten the complete map of the arena. Hence, it couldn't identify the safe spot till now.
Okay.
Once we get the full map, we'll get the safe spots.
Okay. Okay, do you have any issue with illumination? You take care.
Yes, sir.
Some red it was battery was showing red. It is battery is full or not? It was in between, it was showing that red. 34% it has gone actually.
We'll take just 1 minute to review the map which was generated, partial. So, sir, what we're trying to do is we are reviewing the border footage because it detected the 3 side borders perfectly. There was just an issue with the forward border which led to the incorrect map, and that's why we are trying to adjust the gamma S and hue saturation so that it will identify that border perfectly. कौन सा वो वाला सब लैंप्स बंद हो गए बस वो बाकी है सर कैन वी टर्न दोस लाइट्स ओनली दैट या अब कर जल्दी We'll be doing the task again in a minute. Okay, sir, we are ready. Pre-flight check, yes. The landing legs also. Good? Okay, good. Krishan, start.
Somebody is holding the remote control.
Yes, sir, we are switching it on, just pressing a button on the RC and then leaving
No
it.
one is holding remote control, sir.
Fully
It's
auto.
just here.
No, for safety purpose.
Yeah.
Safety purpose, we are doing remote only. We have the kill switch on. Initializing fully auto. Starting. Altitude 3.5 meter. Starting with border sequence. Okay, sir, we are relaunching.
Manually taken over.
Yeah, we are manually taken over, just relaunching. Sorry, sir, he accidentally pressed the manual switch button, hence it. We'll do it again in a minute. Yes, sir, starting again. Rishabh. Yes, sir, starting. Fully auto again. Starting border sequence again.
you can explain.
Sir, error in border detection, we'll assess the errors and fix it. 5 minutes. We'll assess all that and let you know. Sir, we'll need 5 to 10 minutes.
But you can explain. You can explain how long more you can take for this, not an issue. You can explain to the panel. How much time more you will take, you can just tell them.
Yes, sir. Actually, the camera, Logitech camera, which we have for detecting the border, we didn't realize the camera was out of the mount. So it was fallen from the mount. It was dangling halfway, and so it was not a software issue because it identified the 3 perfectly in the first attempt. So we'll fix it perfectly. We'll fix the camera, attach it, check everything. Then I'm pretty sure it will happen.
50 minutes time only, huh?
Yes, sir. 5-10 minutes will take.
explain to you. Yeah, you tell them about that 3D printed vibration simulator.
So sir, okay, so our drone is mixed. First is a 3D printed. We had a CAD model design we made. He made it actually. So we had a 3D printed design for the drone along with the external legs of the drone and legs, landing legs, as well as the X frame. That is market ball, the ready-made frame. Yes. But sir, this what 3D printed novelty what we have is, first we have landing attachments. We'll also be showing the individually actuated landing gears which we have built. So that is mainly for the slope landing which we had done. So even on a very steep slope also it can land. Secondly, we have the vibration isolation mechanism.
First one, how it adjusts during landing?
With the servo motors actually.
Servo motors.
Yes, servo motors. And the second one
So
is the
vibration. Increasing or decreasing the length
yes,
of the.
It is tilting. Basically,
tilting.
it is an external. It is an externally part.
Okay.
Like externally 3D printed apart from the main landing leg. So it gets attached to the main landing leg. Then whatever actuation we want with the servo motors, it does.
I have
that.
seen some kind of V attachment.
Yes, that is the secondary one. So that is not servo based. That is just primary attached.
Okay.
Yes. The second. No, sir. It is not. It is not in the photo. It was not, because that time we didn't implement it. We have design. We have that. We'll show you
Actually, in the.
that. 4 motors. 4 motors.
4 motors.
Servo, two servos, one on each. On the right, on the left. I'll bring it and I'll show you, sir. Yes.
No, I think after completing, they can. You can
Yes, we'll
show.
show you.
Okay. And another one is
The vibration isolation mechanism. So that is specifically built to absorb all the vibration when it falls, especially. So right now, even our drone fell, only the vibration isolation plate broke, and the rest of the drone stayed nice. So what we are doing right now, also we are replacing that vibration with another backup which we have.
Okay.
So whatever the load it is, the plate takes that load.
Okay. After completing, you can show your hardware.
Yes, we'll show everything. We have everything, sir. We'll show. Thank you. Yes, sir. So this is the landing actuation attachment. Yes.
You can tell
Right.
Sir, actually we will be mounting this on the main leg of the drone, and from the actuation we can identify at what angle it is, and the servo will automatically adjust the angle to the plane. So if we have, sir, from the gyroscope, sir, if it lands and the surface is not even, not plane, for the as we use the leveler for the leveling of the house and all, similar technology, by the gyroscope, if it is not straight, then it will automatically adjust the angle to make it straight.
How it gets the input, he is asking. It requires input, no, for adjusting.
Yes, so for the testing we have done it manually, so we are manually doing the servo, but he has also worked out an equation for that, so for the auto also. So it will, the landing legs basically, the drone will autonomously know based on the gradient and on the slope that how much it has to adjust, how much it has to tilt, which leg it has. So he'll, after the demo, he'll explain you the equation, he'll show you that also.
Okay.
For the autonomous adjustment.
Okay.
Yes. Yeah. So the identification. No, sir. Wait. So basically, sir, as we are identifying the incline safe spot based on a certain gradient magnitude map. So similar in that way. So once it identifies that, it has to land, and before that only it will actuate itself that it has to identify how much it has to tilt on what leg. We have tested it manually, sir. The autonomous we haven't tested.
Manual flight, sir. Manual flight.
So manually we have attached the servo motors as per our wish.
Sir, once the first leg or either of the leg touch the surface and the other is going to land, then it will automatically identify that the surface is not even.
Even before this response, the whole machine is so small.
So for the testing purpose, what we did is to avoid this exactly, what we did was we were landing at a very, very slow speed on the incline spot. So whatever the incline, we have a second landing. Yes, sir.
Touch, you depend on touch and then you adjust, yes, or you adjust it before touching.
It depends on the touch, sir.
Please listen. His question is, no, when you are touching, the leg-to-leg touching happens within milliseconds.
But your time scales are different, right? But your
all the legs will not touch the ground. So initially if one touches the see if you have one leg and it touch the ground, and other is in the air itself. So if it trying to touch the ground and it gets the signal that it's not do it, then it will start acting and then it will make it. Sir, is that effective? Sir, how that is it possible for us to one leg like that? If it's possible. Sir, the propeller will be working on it. Our pilot will execute that if it's not in the state anything. The propeller will be that and then it will start. We just need one attempt. That's not that. We have tested on the. So that is already available. We have tested on the 3D landing manual, not on the automatic. Yes, sir, it was manually done. So because of the speed only, we haven't tested it on the automatic. Because for the automation, the speed is 1 meter per second and even more. So we haven't done on the automation, we have done it on the manual. Yes, sir. Yes, sir. We have it just in indoor arena, but it's low. Yes, sir. Sir, if the angle is more than 50 degrees or even the angle is not appropriate, maybe 50 degrees or more, and the sliding gear is that can be maintained more than 50 degrees. Yes, sir. Yes, sir. In case of we allow sir, we have tested it manually. That's what we were testing. We haven't done that on very slow speed. We need to test on the automation and the speed. Actually, we haven't tested it manually. We have tested it now. So we will try to implement that also. And for that, that will be a great. Okay, so here is just from the sensory only, but with the angle of the slope. Then also the leg will adjust accordingly. Implemented. Thank you very much for that. Yes, sir. So we'll implement the camera here. Sir, actually we have tried on more than 15 degree also, but the thing was we have tried manually, not automatic. We have to do it automatic.
Thank you. Next thing you can DJS Phoenix, isn't it?
Yes, sir.
Next time in the meanwhile, will pick up the position and the heading.
Yes,
Either
sir.
is okay. You are chosen that. So
position
this
5.
position is same and heading and heading. Just you can put it back so that. East. East. Okay. East is other direction. Is it okay for you? So it will be fair. You have to start from that.
Okay.
That
And
side.
what's 5?
That is the same place. 5.
Okay.
Okay.
So our navigation system is based on the heading. So can we just rotate it? The location is fine for us.
Okay, fine. Go ahead with that. You take west then, isn't it? This direction
Okay.
facing is okay or?
Yeah, west is fine.
Okay, fine. And I think you know the competition requirement, correct?
Yeah.
From the home position, you have to scan, go up and scan for these 3 safe spots autonomously.
Yes, sir.
And then land in all the 3 safe spots and reach back to the home position.
Yes, sir.
And you have the yellow borders for marking the periphery.
Yes.
Okay, you are allowed to use the remote for the safety requirements. And
Yes.
in case you find any difficulty, you can always intervene and tell
Sure,
that
sure,
you are gone for manual operation.
Yes.
And also in case of difficulty, you tell us any elimination requirement or you want to change the heading requirement or position.
No,
Quickly you
sir.
come back because only we have 45 minutes to 1 hour,
Sure,
that's
sir,
it.
sure.
Okay.
Looks-
Then in any case, if you are able to demonstrate this safe identification is much better. Okay.
Yes, sure.
So you can take up that call.
Thank you
so
so much.
they'll be completing another, I think another 10 minutes they'll be completing. Then you be ready. This other team will be completing in 10 minutes.
Okay.
So immediately be ready for going for the
Yes.
operation. Okay.
Thank you so much.
Sorry, tell me.
You said same mission, so only the position is same, right? The fail-safe or any extra task you give would be different, or
Only fail-safe is only two extra tasks. That is only if battery goes down, you may have to come down, and link goes down also, you have to come down. That is after finishing this here itself. This is the primary task. You can complete that.
बैटरी पुटिंग should be at the moment. हो गया? चल नहीं 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 हो गया ना नहीं 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 गया पीछे से नहीं गया डन डन नहीं 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 हो रहा हाँ विश हो गया चल दो तीन को बस कुछ भी करके हम पकड़ लेंगे ऐसा और काम क्या बोलना सर तो कर सकते बॉर्डर बैलेंस होना जैसा क्लैरिटी वन रन इज चलो डन चलो चला जाएगा मैं तो अपने दोनों पकड़ के छोड़ मैंने थोड़ा सा बाहर आता मत कर थोड़ा सा बाहर आता छोड़ डन डन नहीं मैं बाहर नहीं है Sorry sir, it's okay, it's okay. Local coordinates. Okay, ready. गणपति बाप्पा मोरया वो तो उड़ाले बोलणार आहे बोललो नाही कैमरा वगैरह चल बैटरी लगा अभी हाथ ऊपर करो ना वहाँ से मेरे को बताओ ना मेरे को तो मैं माइक पे बोल चिल्ला दे कैमरा का एंगल देखो तो चिपका हुआ है ना वन रन वेस्ट वॉच अरे छोड़ ठंड है चल पहले कनेक्शन चेक एवरीथिंग So sir, we'll be doing it again. Okay, sir, we'll be starting. Jai Maha. Starting fully auto.
Can we go for the next team? Or?
Yes, the time is up. Sorry.
Okay, what was the issue now?
We'll go to next.
Okay, okay, all the best. Okay, it's good, good, all the best. Okay, right, good. Afterwards, you explain nicely all those 3D printed vibration isolators. It's a good work. We'll get back, don't worry, just come back. Next team can start putting your system there.
Yes, sir. Good morning, esteemed jury members. I'm Akshansh Dwivedi. We are DJS Phoenix from Dwarkadas J. Sanghvi College, which is in Mumbai. And this is our ANAV system for the Martian terrain. Our main algorithm for navigation is a custom-built VIO and SLAM, which uses a monocular camera and LiDAR, which is a 2.5D system. Initially, we were using a stereo system, but we had a crash during the elimination round, after which one of our stereo cameras stopped working. So we quickly shifted on a monocular camera or the same camera. Our SLAM is better than others on the market because we are using keyframe based navigation SLAM, which is much more efficient. So it runs on our Raspberry Pi itself. We are using a Raspberry Pi 5, so it takes keyframes at regular intervals. So our drone is taking off, let's say it's at 0,0. Then our threshold for creating the SLAM maps, it's a graph based data structure. So the difference, when it goes ahead by 0.5 meter, it adds a new node. Each node has data of the features that's down there on the ground, that's saved in the node. And the edges which are connected by the node shows us the displacement of the drone, that how much the drone moved. So by that, whenever the drone is coming back to a spot, it can match those keyframes, that it matched to keyframe number 6, which was previously added toward in that node, and it can avoid drift. So that's what we use to avoid drift in our own VIO system. Coming on to our visual inertial odometry system, so it works based on 3 major sensors. One is a monocular camera, which is a black and white camera. We are running it at by 640 by 480 pixels. So, and a LiDAR sensor and an IMU sensor. The IMU sensor and the monocular camera are both in the Ogdilite camera module. Both are synced together in an interval of 10 milliseconds via timestamp, so that there is no drift or duration gap. We are using the LiDAR to sense the exact distance from the ground. We have 2 LiDARs actually, both are TF Mini. We take the average of both. We get the distance from the ground. We track the features. We track the features in the next frame. We see how much the features have moved, and based on the angle it has moved and the distance, we decide the distance the drone would have moved in the upper frame via tan theta. There was a challenge about this when the drone is moving forward. It's a bit tilted. So we added, based on our IMU, radians per pixel parameter, so that when the AHRS tells the drone is tilted towards further, it accounts that for the displaced LiDAR because it's looking at the sideways. So this is our main VIO and SLAM system for navigation. Coming on to the detection of the terrain and how we are detecting the landing spots. So we are using a edge detection model, which is more superior as it's an image processing model to other neural network based models or machine learning based models. So we are detecting edges of the terrain which is similar to the rocks. We are applying filters, morphological filters, which is opening, closing, dilution, to detect flatter spots, which don't have such high terrain. Also, as you can see, our custom GUI, which is an open source GUI, which we have created for this system. Here you can see the navigation of the drone will be visible, which hello, yeah, which will be north, east, south, west with respect to the current drone's heading. So north would be towards this side for the drone. Based on the VIO we are doing, and as I said, we have 2 LiDAR systems. So both of those LiDAR systems are 20 centimeters apart, based on which we can evaluate the angle of the terrain. So the terrain angle will be visible here. Both of the LiDAR's live data will be visible here, distance sensor 1 and distance sensor 2. And here's the position data and plotted. Here's the system status, which is the battery 16.3 volts, the EKF flag, which just tells us that all the system is running correctly, distance sensor 1 and distance sensor 2. And this is just an artificial horizon. And so we will be plotting a 3D scatter plot onto a 3D position based on the XY coordinates we have from the VIO and the Z coordinates we have from both of the LiDARs. Initially, the preliminary reports we sent and the qualification reports we sent, we also had an optical flow sensor, but we found out that during our calculations of VIO, we are also calculating vision speed estimate and vision position estimate. So we can use the vision speed estimate of that instead of the VIO, so instead of the optical flow. So we are also running the optical flow on ourselves. That gave us an extra UART port which we used for the other LiDAR sensor.
Border detection logic is based on which sensor?
Sorry, sir?
Border
detection is based on Sobel filters. We even experimented with Canny filters, but the camera which we are using is an OGD-Lite camera, which has a VPU inside, visual processing unit. So it already has a built-in feature of Sobel filter detection, so it runs better.
Color camera or monochrome for that?
It's a monochrome camera.
Okay.
We have a color, but we aren't using it. Also, one of our major USPs is the affordability of our drone. So the complete system comes under 60,000, which is equivalent to a Pixar Cube plus a Jetson Nano or a Pixar Cube plus Intel RealSense. So it's just 60,000.
If you are ready.
Action.
Yes, sir.
Go ahead with the, if you are ready, please go ahead.
Yes, sir.
Operations, okay. Ready? And you are going to demonstrate fully autonomous?
Yes, sir. First demonstrate fully autonomous.
Okay.
Yeah, safety, RC is handled by a pilot Om Tank. GCS is controlled by Divi Nandu. Yeah, you can come inside, Om.
Yeah, please go ahead and announce what are the activities going on.
Yes,
okay,
sir.
Please go ahead, yeah.
So, our first navigation.
It's okay, whichever is comfortable.
No, I can display on here also. Yeah. For initial navigation of the drone is not based on the color or the border detection. We tried border detection, but it was overwhelming our process, as Hugs transformation was more expensive as it was N square. So we are not using that. So we, for the navigation purpose, that is the surveying purposes, we are using a heading, constant heading. Yeah.
Now, are you ready? Team is ready for starting?
Please. No. Yeah. Yeah. Yes, yes, sir.
So they started.
Yeah. So the drone is first taking off at an altitude of 4 meters. It will hover there at the safe spot, 0, 0. Then it will go to 1, 1, 1, 0. It goes to 1, 0 and it hovers there for some time. It starts detecting. Oh, our battery dropped to 14.9 volts, so there was a battery fail-safe.
Now, what is the voltage set for battery safe?
It's 14.8 volts currently.
Okay. See, why very short time?
Yeah. Can you just... Sorry?
Why the battery got drained?
I think it was majorly because for 4 feet it gave... what do I say, the throttle rate of above 85%. So the lithium ion cells drain earlier when a higher throttle percent is given. Divi, just put the takeoff to 2 meters. Yeah. And battery fail safe ko 14.8 se just do it 12.
Okay, are you ready now?
Yeah, just 1 second.
Okay. You are changing something? Okay.
Yeah, we are changing the fail-safe to just 12 so that it doesn't affect right now.
Yeah. So did it autonomously come back when on fail-safe?
Yeah, it autonomously came back.
Okay, you got it demonstrated then. Okay.
Yeah.
Battery safe. Okay.
Are we ready? Yeah, we are starting again. Run it again. Unbooted. Varun, just disconnect the OGD and reconnect it. Disconnect the OGD and reconnect it, yeah. Restart that also. Escape. Yeah, try running it again. Yeah. We are ready. Just reset that. Yeah, we are just resetting the GUI and we'll begin. Control C. Scroll reconnect her. Give a second. COM4. Yes, connect. Restart this. No, that's fine. Yeah. Com. Started. Om. Yes. Let it go. We had a manual intervention because of an X-link error. Yeah. Run it again. Om.
Should this time?
Go ahead.
Again, same issue. We are getting an X-link error, which is the OGD getting disconnected via the USB cable. So if the OGD it gets overburnt. So if it just cools down for some time, then after that we can run it again.
Okay, okay. You didn't face this problem in your tests?
Yeah, we have faced these problems.
Okay, okay.
Yeah. Yes, sir. Yeah, so X-link error is OGD light camera has different nodes in the pipeline which it runs. So when one of the nodes, processing nodes, doesn't give the connect to it, so it gives an X-link error. So our syncing node is getting, we get it usually when the processor in the OGD is getting overwhelmed after heating. It's a mechanical problem because of some overheating. After the crash, it overheats a bit sometimes. Yes, we have noticed it in all our practice sessions. We know it. So we tried to reduce our IMU hertz rate. It got it down a bit, and we tried to optimize our code to make it more leaner. But if we make it more lean, then we won't get the accuracies. If we can just cool it down for a bit and show you.
What we are seeing is it just goes
yes.
up, stays there for 10 seconds or so and comes back.
Okay. If you want, we can just once show, record a, he can just once manually go over these and we can just record a video to show the algorithm work and then we can cool it down and do the autonomous.
Yeah, it's okay. Yeah, that's what you decide quickly. But, okay, you want to manually scan and show safe detection?
Yes. So.
Okay. How quickly you can do?
Yeah.
Go ahead, yeah. Go ahead with that.
DV? Hmm? Yes. Om, manual. 1 second. So about 20 minutes, 15 minutes. So manually mostly same error है, उसमें processing same लगती है. Start in 10 minutes. Yeah. So, even in the manual takeoff, it can heat up, and so we'll just resume in 10 minutes, if it's okay.
Yeah, yeah. No, for manual, you need another 10 minutes.
Sorry? There was also another thing that it may be draining power, that 1.2 amps is required for the OGD light camera, and if it's not getting enough of those, it might damp. But we tested via multimeter and we didn't think that was the issue. Yes, sir, we are aware of it. If it just cools down. So we can just, sorry? No, the battery was normal because of the processing running on. We'll just let it cool down a bit. So we did face the same issue down also, but the thing is, we even tried using an RDU cam directly on the RPi, but then all that computation won't just happen on the RPi CPU, because running the matrix kernels on a CPU is very time consuming. OGD has a VPU, so we had to utilize that, so we couldn't change the camera. take an attempt at the autonomous mission once again.
Laptop.
Is it the manual scan you are doing?
Yes, sir. It will make sure it's at the altitude we have given and start navigating forward.
Can you repeat? You are doing autonomous only?
It will make sure that it's at the altitude we have given the input in and go forward. We change the altitude once. 2.5.
Minutes.
Do nano navigation. एक बार मैनुअल करता है, you just detect all the safe spots and angles.
यहाँ से रिस्टार्ट करवा दे, जैसे
Okay, so now just to demonstrate our safe spot landing capabilities, we will first try a manual attempt. So as you can see, our map is being built based on the features that the downward facing OGD camera is tracking, and it builds a 2D map in this NAD position. And we also have integrated with that with the LiDAR, two LiDAR sensors that we have mounted to build a 3D position history that shows the exact movement of the quadcopter around the arena.
RC controlled.
Okay, what was done manually? You scanned the positions. Could it identify the safe spots? That was the idea, isn't it?
As we have recorded the video,
okay.
So when we see the video, we can also see that on the output terminal of the ground station,
okay.
That the camera detects the edges and it identifies spots that are, it identifies safe spots that are free of boulders and edges, and thus it qualifies them as safe landing spots, and that we can see on the output video.
Okay, your scan is fully complete because it didn't complete fully, no? Did it complete fully? You were planning to do full scan, isn't it, or no?
Yes, so
what was your plan?
No, so we just wanted to show like one or two of the landing spots being detected in the output video, so that's why we just flew once over the manual, so we can show the output video.
Okay, now we will be able to show? Okay.
Yes, so we'll just demonstrate that.
Okay, how much time will take? Just 2 minutes. By the time I'll ask other people.
Yes, so we'll just need 5 minutes because we disconnected the battery. We just get the video from the onboard computer and we'll show the output.
Yes, yes.
Any questions if you have?
Yeah. The Sky Sovereign's team, you are ready? Are you ready, Sky Sovereigns? Yeah, you can just come here. If you are free, you can just come. Yeah. Just to save the time, we just want to start some of the activities. Okay, you are Mr. Amandeep Datta, yes. The requirement is that you have to take the safe, so it means home spot from here. There's a location and to just have a random selection of location and the heading angle. I hope it's okay for you, any heading angle and location, correct? No? Any location is okay for you?
Yeah, okay.
Okay, you just select a point. So you just find the number. What is the number? 5 actually the same point, okay? This you take one more from here. That will tell you the heading, the starting direction. Sorry? West, okay. It's towards west, almost like this. You have to start from here, okay? And you know the competition requirements, isn't that? From the home position, you should go up to 2.5, in the order of 2.5 meters, and scan and get all the safe locations, and supposed to land in all the 3 places and go back to the home position. That's a primary requirement, okay? The requirement is that you have to do it autonomously, correct? All these operations autonomously after giving go, okay? And you also have a periphery marked by the yellow strips, okay? Those things also have to be detected. And in case you find some difficulty, you have to intervene manually. In case of any safety requirement, or you find it's not going properly, you can intervene, okay? And you have to inform and intervene. Accordingly, we will take care, okay? So in case you are not able to do autonomously fully also, if you are able to demonstrate the safe detection autonomously is also a good way of handling it, okay? Then other things, you may have some 3 attempts and only time is limited. You may have to try to complete all the operations within 45 minutes to 1 hour. That's it, okay? So that's why you save the time for setting it up and be ready for the operations, okay? Okay. Right.
that our drone has to. Yeah, you said that our drone has to face to this direction, right? But actually, according to our code, we have to face to the yellow line, so that we can track the yellow line and. Yes.
Not direction. We need to see the not direction.
Yeah, thank you, sir. No, that's not. We have to.
No, sir. No, sir.
No,
we
yeah.
need to see the longer line of the yellow line.
Yeah.
So we'll face the not direction.
Yes. North. Thanks.
Processing the hours of 5 minutes in their team. Phoenix. They told better they take us manually they show the character manually they want to show
So due to the crash, the video didn't get saved. We'll attempt autonomous once again. So last time, if it's viable.
Okay, you want to attempt automatically, no?
Yes, sir.
Autonomous?
Yes, sir.
Okay.
So, any questions you have? Yes, sir. So, because it crashed, the video didn't get saved. The frames, we have got the frames, but they got corrupted, so it's not getting.
Oh,
a
okay,
video.
okay.
Yes, sir.
Okay, autonomously you are going or
Yes,
manually?
sir. Autonomously.
Autonomously, it will
Yes, sir.
scan? Okay.
Yes.
Is it really autonomous, or in previous round you have marked the coordinates?
No, no, sir. No, we haven't bugged any coordinates. You can check the code. It's purely autonomous.
Okay.
Only the navigation part is something which is hardware. We go to scan, go towards the forward direction. Yeah, manual करना है without crashing. बहुत ऊपर से.
Time is over.
Yes.
Phoenix team.
टाइट कर देना केबल केबल USB. हाँ sure.
That is called RC, sir, remote controller. How to see there also, how to see there also, how to see there also.
Again. So you are attempting to do
Yeah.
autonomously?
Yes, sir. We'll just change one more parameter.
So your time is up, and then 5 minutes to take, and then tell me.
Yes, sir. We'll ask slide.
2 minutes to take.
Okay. Last. Om. Run it. काम नहीं हुआ X-link error. Home. X-link landed. I'm really sorry.
Okay, it's okay. Okay, don't worry, it's fine. It's done. It's good, no problem. You went for the scanning and you want to show something that you offline if you want. Could you get any safe spots?
Sure.
Okay, good attempt, and okay. That's good.
Thank you, sir.
All the best. All the best. We'll call the next team.
Hello. I'm Hello, esteemed judges. I'm Amandip Datta, the team leader of Team ID 10061, NITS intern of the Sky Sovereigns. And we are representing NIT Silchar from Assam. So we have developed an autonomous drone, which basically scans the arena based on the yellow line first, and then based on the yellow line, it it creates a some set points, through which it does a burst of radon scanning. From the scanning, it detects the flat areas. Okay, we get the coordinates, and then it initiates the landing commands for flat area 1 and flat area 2. After landing in flat area 1, it takes off, and then it comes to flat area 2. Then it goes to flat area 3, and then again to flat start point.
First, it has to complete the mapping, is it?
Yeah.
Then only it will go for the
yes.
location. Okay, fine. So you'll be able to identify whether it is mapped correctly first?
Yeah. Okay. Yes.
Okay, fine. So what algorithm you are using for identifying the safe spots?
Ransack.
Okay.
Ransack, which basically detects three spots in a plane, 3 points in a plane. Okay, so that it lies in the same plane or not. It takes whether the jet coordinates of the points are within an area.
Okay, fine. So you'll be able to identify these boulders as not flat, no? Because it's a smaller boulders. You have tested in similar configuration?
We actually, in our arena, we used this one only. We didn't use boulders. We used by sand, humps of sand.
Sand, okay,
yeah.
Okay.
Well, let's see.
Okay, fine. Okay, right. Okay. So what are the sensors you are using?
We are using Intel RealSense D455 depth camera.
Okay.
Which has a IMU. Also, we are using PixHawk 6X, okay, which is the flight controller.
Okay.
It has the barometer, magnetometer, and the IMU also. So we fuse the camera and the PixHawk to get a...
Okay. The initial scanning, you told you wanted a yellow line out to the right, isn't it?
Yeah.
What was that requirement? From there only it identifies your boundaries.
Yeah. So the thing is, it will first detect an yellow line, and it has to be parallel. So, and it will go parallelly, and then it will detect 1 point. And then it will come again, like this, and then it will come here. So like that, so that we get all the points.
Okay. And you can say if it has identified the safe point also, or not?
Yeah, we can.
We will be able to find from base station?
Yes.
Okay, that also you tell, then now it proceeds.
Okay.
We tell that, okay. Are you ready now?
I have to go with it.
So we will be starting now.
No, it's possible. It is possible.
Light switch off number. Light switch on matter.
Switch on.
On.
You wanted lights off or
on? On.
All lights? The side lights?
Will side lights affect? Side lights? Huh? Side lights might affect. No, sure. Those हाँ? इसको बंद करवा दूँ? इसको वो वाला लाइट सामने वाला वो सामने सारे sir, can we just the front one?
All light switch off matter. Fine.
Done. Ready? फिर से देखें. इसमें से क्यों? हो गया? आर में मैं टेक ऑफ नहीं हो रहा ना.
You want these lights to be off or you can? So you switch off that light, is okay?
You can explain. Any light you can explain.
It's like it's not something.
Yeah, no problem. Tell.
there is some issue with the launching.
Okay.
We need some time.
Oh, you need some more time, is it? How much time?
We have to solve it because it's not launching.
Okay.
Yeah.
So 10-15 minutes will take? Or?
Yes, let's see.
Okay, can we ask the other team, next team to come then?
We can wait for 10 minutes.
Okay. What is the issue? You are able to manually do it also? It's okay. Manually scan and show or some different heading. Okay.
We'll try it. Sir, the node which we had, which does everything autonomously,
Okay.
it's actually not working.
Okay.
Now
The node
for
means
some
that's some
reason.
processor interface. Okay.
But now we will be doing the exact commands which the node gives. We'll
Okay.
be giving the commands in the laptop, in our
Okay.
terminal.
Okay, manually.
Manually.
Okay, with that
But
you can demonstrate?
Yeah.
Quickly you can do?
Okay.
Okay, go ahead, no problem. Okay. So manually you will give those commands alone?
Yeah.
And then with the scanning, what will happen? It will do the
It
scanning?
will do the scanning.
Okay.
There is no problem with
Okay, it will do the scanning and the safe it will identify.
Yeah.
You will be able to show that.
Yes.
Huh? Okay.
Sorry, sir. We want to debug the code to show it fully autonomous. Can you? We can ask if we get the second chance.
Right now, we might consider only after the 7 because other people are also there.
Okay.
Okay, I think another 15 minutes only time is there.
Yeah.
You can go and come back. You can go and come back. Then
Okay.
later we'll see. Keep ready. After finishing the 7th team, 15 minutes time we'll give.
Okay.
That should be okay.
After
the last two more teams are there.
Yeah.
This team is there and another team is there.
Okay.
After that, some 15 minutes.
Okay.
Yeah. Okay.
If time
By the time you
permits.
keep it ready. So because you have another 15 minutes time to complete, so that 15 minutes we'll give later.
Okay.
Okay. Right. So shall we ask the other team? Other team is ready. They are telling. They are ready to. Yeah. So Team Surya, if you are ready, you can just one of you can. Team Surya, who is going to come? Yeah. Team Surya, no? Come, careful. Careful. Your name is? Karthik Pandey.
Sir, Karthik Pandey.
Yeah. Yeah, the position you can select from here, one of the positions.
Thank you so much, sir.
Just this, yeah. Okay. You can take one position out from here. Pick one paper. Sure. No, yeah, it's okay. So the question is, okay, 1 minute. Question is position one, and that direction also. The other one, you pick it from it. Okay. Yeah. So heading west, okay. So west is this direction. Sir, position 1.
So west is just like you're facing
this direction. 1 is somewhere there. Okay. Okay, it's okay. Any position is okay for you?
Sir. Huh? So no questions. We are good to go with the position I have chosen.
Okay, fine. Okay. Go ahead. So and the thing is, I know you know about the competition fully. From the home position, you have to go up and then scan for the 3 safe spots. Okay. And go to each of the 3 safe spots in any order and go back to the home position. This is a primary target for you. So this is, you have to land and go up and go back. So this is supposed to be done autonomously fully, including the mapping and finding the safe spots and going back to the position, okay? And you know that periphery is marked with the yellow lines, so that you have to take care. You are expected to do it autonomously. In case you have to intervene manually, you can do so by informing. And if you are able to identify autonomously the safe spot is better, okay? That you can take a call. And manually doing, accordingly, it will slightly marking will be lesser, but you can take a call for the safety reasons and as well as you want to intervene in any case, okay? That you can do it. And in case you need, anyway, heading position and this, anything is okay, you are told. In case any illumination requirements are there, you can identify and tell immediately.
Sure,
okay?
sir.
And I understand if you want to do fully autonomously or not, you can declare now. You tell now. Okay. And you want to tell anything about the system, you can do. And in 2 or 3 minutes, you can go ahead with the actual.
Okay.
Yeah, please go ahead.
So let me introduce my first. So myself Karthik Pandey from Sharda University. My team name is Team Surya and the NF name is Dr. APJ Abdul Kalam. And my team consists of 3 members. Myself, the team lead, Muskan, the team co-lead, and Prashant, the team member. So basically what we are doing is, firstly, we will fly our drone fully autonomously. And we won't do any manual intervention by default. If anything will be happen, we'll take the command at that time and we'll inform you as well also that we are taking the command. So from starting, from the navigation part, what we are doing is we are not relying on any pre-built or custom-made or like any like market-ready systems. We have procured our own navigation algorithm that is depend on the system drift and that we have built completely on ourselves only. My team has built that, and let me introduce that also. Prashant, can you just show the sequence? Okay. So let me just brief you about the navigation algorithm, what it does. So what we mean by the what the autonomous system has to perform. So let's suppose any system is there in a arena or in a Mars situation like. So in that situation, the drone should be free for any natural causes. If we'll restrict that drone to follow a single path, then that will cause the drone to lead to crash. So we have given our drone to freedom to, we have given a confined area that you have to be inside that yellow line, and then we have given the objective, you have to do this, and after that our drone will take any path required and defined at that moment of time. Because that path will be, if we'll define that path, then maybe the drift or the environmental condition could affect that, and maybe the drone could not follow that path, exact path. So, and one thing also, sir, actual thing like the actual true path could never be specified or could not be achieved, and the imperfect systems are the one like those are like mainly perfect. So our system, we are using the imperfectness or the drift. We are calculating the drift, what the drift system is giving, and then calculating that drift. And we are not giving the drift to cover that system. We are okay with the drift. We are using that drift to navigate the system inside the arena. Our NAV knows that this is the arena, this is the size, and I don't have to go outside that. So what we are doing is, my drone will, I've just given it that, okay, you just need to traverse the arena. All the drifts, it will calculate the drift. It won't improve that or improve the trajectory. It will just calculate it, and after calculating, use that drift to navigate inside the arena. So this is how we are working, and that's how the system could be perfectly autonomous. Because if we'll say that, okay, just go from A to B and using this path, so this is not from our point of view, this is not an autonomous path. This is a guided mode. And what we are doing is we are doing autonomous. We just said, okay, point A to point B, path will be chosen by the drone according to the conditions only.
How often you are computing the drift?
Yes, sir.
Are you continuously computing the drift and
yes,
taking care?
Sir, we have an external sensor. We have only, sir, we have 3 sensors. A dedicated sensor for calculating the drift only. And we have 2 cameras, 2 serial vision cameras, one mounted in the front and one mounted in the bottom. So the front facing camera is a navigation camera. It is a RealSense T265 tracking camera. It provides us a pose of the drone, and we are tracking that pose. And we have also another system that is we are calculating the drift from those differences. And after that, calculating the difference from the error, what it is giving. And after that, the error will be calculated and used in the navigation sequence. So, yes, sir. Sir, tracking camera, sir, actually the name of it is tracking camera because it has a fisheye camera. It is a wide angle camera, wide angle 2 cameras. So we are using those 2 cameras, and we are fetching the streams, calculating it, and we are defining points. Okay, sir, we are using this camera to calculate the drift system is getting. We are not providing any path to this NAV. NAV will choose its path. It know where I have to go, what I have to do. That's it. Sir, we are able to calculate the drift by using that camera because that camera has a fisheye view. So we are getting the input from that stream, and we had another system also that a velocity system. You can say MTF01 is an optical flow camera. It outputs the velocity of it. So we are getting the velocity from both 2 sources, and we are calculating the difference. Optical flow has a better you can say accuracy, and the tracking camera that has that is built with the pose systems. So that pose, yes, sir. So we are using this thing to navigate. Drift is a bad thing for us, but yeah, we are using that as a weapon for the drone, for the navigation part only. If we'll guide the drone to just take the single path and you have to stay at this path only, then system will most probably crash. Because we don't know the conditions there, what the condition will be there, and we even don't know what the condition they here also. That's why, sir.
How we are identifying the safe spot?
Ma'am, we have a dedicated, okay, so coming to the second part of the, ma'am, we can say we have a second part of the mapping and landing order. So in that, ma'am, our drone has a dedicated depth camera, in RealSense D435 depth camera, mounted specifically for only detecting the safe spots. It is not doing any VIO, winds and all of that. It is simply used only for the detection of the safe spots. Ma'am, our camera, our algorithm finds a single, continuously finding the path as the rover traverses inside the arena. And as soon as it reaches any spot, it finds 5 best routes to land that. After that, it chooses the best one. We have set it the order, which order should be perfect. Like the bottom one will be best, or if some wind condition will be there. So according to that, it will calculate the drift, and it will analyze, okay, what's the drift and how will be my trajectory. So in traditional way, what happens is drone can directly set mode to the land, and in that it just directly come down. It doesn't check. So in our case, we iteratively check at each step. That okay, we are checking and realigning itself to the spots. That okay, our path is correct or not. So
Karthik, if the team is ready, they can start keeping the system.
Definitely, sir.
Other team is ready.
I want to show my sequence first. Actually,
okay, you can.
This is the sequence. Firstly, we will demonstrate you. क्या हुआ?
Karthik, the team is only you have 2-3 people. Other person can keep it there if they are ready. Okay. If you start setting it up.
Prashant, show the sequence first.
just in between one question. What is the role of vibration sensor here?
Sir, vibration, sir, we are like trying to reduce the vibration because vibration is already harmful for a system. We are using drift calculations. Actually, there is an actual truth and
vibration sensor, so just
yeah. Sir, we had a vibration also. Sir, actually, because system will be vibrating bluntly during the flight because there are like 4 motors and that rotates around 750 RPM. And so 750 RPM produce a huge amount of vibration in X and Y axis. And that could lead to the internal drift also. Like we could deal with the external wind speed, but we can't deal with the internal systems, internal hardware system. So that's why we had a vibration sensor that, okay, let's reduce the like motor speed to like reassure the and to reduce the vibration. So that's why vibration sensor like it is very necessary for us.
It is used in closed loop.
So yes, sir. It is used to stabilize the drone, to reduce the speed of motors. Like,
but if you reduce the speed, it will come down.
Yes, sir. It is. But sir, what happened is, if we want to go from A to B position, then in that case, there are multiple options that we could go slowly also. If the drone will go very like swiftly, in that case, it will analyze that, okay, my speed is very fast and we can slowly, we can also reduce the drone speed to, like there is a threshold value also, sir. So actually threshold, after threshold, it will calibrate, okay, this is the extra like pressure or extra vibration that is coming due to the speed. So it will just reduce the speed to threshold level, not below that. Beyond threshold, it will just drop down. So we won't be doing that, sir.
Okay, then one more we are telling you are moving only by drift. Then how we are, suppose you are touching a boundary, how you are coming back?
Okay, so let's suppose a condition, we are moving and we are nearing to the boundary. So our camera has, like I said, that it knows where to go and it knows, sorry? Just show the sequence first. Okay, so
if the team is ready, you can go ahead with setting it up.
If you are ready, go ahead.
Okay, so we'll answer the question. Show the sequence first. Sequence, so first sequence.
Yeah, you can go with them. No
Sir,
problem.
please give me a second.
It's okay. It's
Show
okay.
the sequence first. Okay, so as you see, we'll go structurally. Firstly, we will show the, like we can localize the system. After that, we'll show you, we can map the system perfectly. After that, we'll go for the task performance. Hardly will take 5 minutes to demonstrate that. So please allow me to do that. Please. Okay, thank you so much. Yeah, Prashant, please switch to the localization part. Okay. No, localization. Okay. Okay, so as you can see, this is the environment. Okay, and my teammate, my team co-lead will move the drone inside this area, and you can see the yellow means it has a lower confidence, and as soon as it lifts, it has a better confidence. So she is moving, as you can see, she is moving, and she will traverse some area, and again she will go to the same point, and you can see it has know where it is started, and it will see she just came back and it is there only.
Okay, that's good.
So this is called the localization we are doing. So we had a perfect localization first, as you have seen. If you want, we can traverse more of the arena.
Right, it's okay.
Okay, so you can shift to the mapping part. Yeah, depth part. Okay. Sir, as you can see, we had multiple sensors here. This is the tracking camera we are using. The tracking camera can able to localize it very easily. No, sir, it's good, sir. We had a good grip here. Sir, this camera provides us a localization. And sir, not the ready-made, we have made this customly. Okay. And sir, this is the depth camera, the normal depth camera you have seen over here. So this is the normal depth camera only. What, sir? Sir, 90 FPS. 90 FPS, sir. Sir, actually, it is made only for 60 FPS. We have tweaked some things internally in this, and after that, we have this 90 FPS in this. By the company Intel only, they provide 60 FPS, and we have switched to 90 because 90 is way more better for us, like than 60. Okay, so this is the depth camera, and we have the like our TF like MTF01 here. It is the optical flow. This is the depth camera for dedicated only for the landing spots, only for the landing spots, and this for the tracking, dedicated for the tracking part, only for the navigation part, and for the drift calculation, we have this. Okay. Okay, so she will demonstrate you how, sir, she will demonstrate you the second sequence part. It is showing about you that how we are landing in arena, how this works. So as you can see, okay. Okay.
And if I move it like this, now it's
Muskan?
not a flat surface. Basically, based on the depth.
Let me give me the drone. You just explain. Okay. So as you can see, sir, right now it is showing 1 over there. 1 means that a default path, single path. As I remember the order, it is the first order. And as soon as I put my leg there inside that, it is showing a 2, 3, and 4. So there are sequence and to landing the same path. We have many you can say trajectories, multiple trajectories. We have 5 trajectories for the single same spot. If you want to land here and the drone is here, so it will just go choose this path. Sir, okay. So you have to turn this off. So, sir, talking about the FOV, you are working FOV. Sir, it depends on FOV. If actually my drone is built for the flying one. I'm telling sir. Sir, actually, we have made this drone to fly at a 2-meter altitude to maintain this 2-meter altitude. At 2-meter altitude, it covers the area of around 3 meters by wide and around 1.3 meters by length. So,
yeah. Karthik, in real time when it runs, you will be able to show the same images?
Yeah, definitely, sir. You'll be looking at that.
Okay, then good.
Karthik,
okay, definitely,
good.
Sir.
Good. We are able to demonstrate.
Okay, sir. We are moving to the third sequence.
Yeah.
Yes, sir.
No, you told the drift you will be able to use it for navigation. No?
Yes, sir.
If the drift is of not the desired polarity, how it will converge?
Okay, sir. It will calculate the drift first. That what's the drift? Is it able to land and stay to navigate? If it is possible, it will give the warning. The system can't handle this drift. It will just land over the same place again. Okay. And sir, if it is nearer to the yellow line, then there is the sequence as said. We have tracking also, that where the drone is inside the arena. So it will just track the yellow color also as we have there. So there is a full frame. Inside the frame there is a smaller frame for the detection. Outside the frame we are only for the yellow detection only. So that we make sure that drone won't go outside the arena. We confirm that drone won't go outside the arena during the round, as you can see.
Okay.
So we are heading for the third part, the main task performance. So Prashant, please arrange the telemetry. And yeah, put it.
Yeah, correct.
May I help you? Battery charge? Okay. Okay, fine.
Karthik, you are okay with the lighting? If you need some more
sir,
or
give
less.
us a minute, we'll configure that also.
Yeah, okay.
Turn off that. Sir, can we turn off the lights there at the left?
Sorry, you want to make it off?
Sir, light at the left of the wall. There. Lights of the wall. Left wall, sir.
This also?
Yeah.
This also will make off?
Karthik, the behind one is okay? The behind lights.
Karthik, you
sir, I'm coming, sir.
The behind lights.
Yeah, turn off that also. Yeah, off, turn it off.
And this side?
Confirm? Off. Please make sure that all the terrain lights are on. Please make sure it. And I want to confirm that light should not go immediately inside the roof, please. So don't just turn off mid-flight. I request, please. Okay. Okay, sir, we are ready. Yeah, we don't want to do any pre-configuration. The drone will be calculated itself.
Okay, you will do autonomously. You will go. Is it?
Yes, sir, completely autonomous.
Okay, good. You
so, sir, just like before starting this thing, I want to confirm that what we are going to do. Initially, she was there for the emergency things. She has the only control to do just landing the drone only. She has nothing control to like move or like to traverse anything. There are two RCs I can show. One is the main RC. Give it to me. We had a main RC here. This RC has a full control of like you can say manual intervention. She has the only thing that she can do is that to land at any position she like. She has the only control to land. That's it. Yes, sir. No action, sir. So she's there only. So there's the auxiliary RC. There's the main RC. Yeah, sir. Actually, she is just raise her hand when there is an emergency. I'll just look at where. So we have a protocols already defined, sir. Okay, so let me explain the telemetry. This is the you can, as you have seen, the localization part. It is actually green, so it is confident that will do better. Yes, sir. Sir, it will take around 10 minutes for us to do this task, actually. So, definitely. Okay, this is the, okay. We'll end also. Okay, thank you, sir. Okay, so starting the mission. Everything is initialized. Prashant, ready? Muskan, please be patient. Okay. Prashant, ready? Okay, we are heading for the mission. The drone will take off in 3, 2, 1. Jai Hind, Jai Vigyan. So it is connecting now. Muskan, I'll tell. Don't worry. Ready? Throttle down. Everything is perfect. It is connecting. Okay, it is arming now. Drone will take off in just a moment. It is on the 2-meter height. It will now move forward and it will calculate the drift first and then accordingly it will navigate inside the arena. So it is moving backward and scanning bottom. Oh, now it is moving forward. As you can see, it is height is variable because due to the obstacles, it is like up and down. No. So, Muskan, raise the RC up. Raise the RC up. Yeah. She's not doing. We have the main RC here only. It is only controlled by that person only, the base master. It is traversing on its own. Now it is find the safe spot and disarmed and closed. So let me, okay, now one thing I want to confirm that, okay. Only disarming, sir. I'm confirming what has happened here. So first, it is configured that, okay, I am the spot. Here is a spot beside the drone. Secondly, as you said, it just came down. Ma'am, as I said that, it just reconfigured that I am at the same position again, not at the top height. It just came down and again reconfigure and realign itself to the spot again, center. As you can see, it is landed on the center only, not beside that. And ma'am, as you can see, it is not a perfect center because it is calculated on the rocks, base of the rocks. So if you will calculate from the rocks distance, it is center part only.
Karthik, did it show?
Yes, sir, completely autonomous. She has raised the RC in between flights, sir.
Karthik, did it show any green points there as per you?
Yeah, definitely, sir. So, no, sir, actually what happened, it is landed. So that activates only above the 2-meter altitude. So
okay, I did notice that time. Okay, if it did. Okay, okay, you proceed further, Karthik.
Okay.
Karthik, you proceed further and then.
Okay, so right now, as I want to confirm first that we haven't done that from a single command. It will just land, and sir, we have watched the video on YouTube of these tasks, so we didn't want to risk. So I want to confirm from the audience that okay, we will go for the second round. We'll just hit another command, enter only, just only enter, to again traverse area and again move. So
okay.
Can we do, sir? Okay, Prashant, we are ready. Muskan, wait. Muskan? Sure? Okay. So we are ready. In 3, in 2, in 1. Yes, go. Yeah, it is connecting now. Okay, okay. Okay, now she's open that now drone is able to freely take off. So preparing for the lift off again. Muskan, I'll tell for the throttle down. Everything ready? Okay, we are going. Sir, actually these are all the security protocols we are following. We have already decided that what we'll do, so that's why we are talking too much. So, disconnecting you down the throttle. Throttle down. Throttle down. Sure? Prashant? Okay. Disconnecting now to the vehicle. Again it will arm. Drone is armed already. It will take off just in just a moment. It is taken off already. As you can see, here's the camera feeds are also, you are requesting that how we are sensing the yellow line also. So here you can see, this is the field for the yellow line only, and this is for the safe landing spots only. So these blocks are top and bottom blocks for the drift calculation, and as you can see, it is going backward again, because it is sensing that where is the safe spot, and it doesn't know any coordinates. I want to confirm again also, we haven't used any coordinate system here, no coordinates, only drift calculation and randomized navigation. We even don't know what will happen. Yeah. What happened, sir? What happened? Sorry for that. Sir, I want to just say what happened. Actually, the battery strap was sticking with the. Yeah. Sorry for that, sir. Okay, just bring the tape.
To this spot, landing was at a manually out. Sorry?
Override everything.
So you landed autonomous manually.
Manually. Sir, I am telling, sir, what happened. Sir, actually, the strap was there open.
Understood. Good, no problem. You correct it and go ahead.
Okay. So the strap was open. She just put it the one switch that, land at the last spot detected. So it went over there and landed. Yes, sir.
Your task, focus there and.
As I said that the main RC was there, she was only controlled to turn the drone like to the land mode. So it just went to the last spot again at the same position. You can see at the camera also.
Surya team, we all want you to perform. So we want you to focus, first complete the task, give the demo properly, complete the task, then we have question answers, okay?
क्या हुआ? I can go. No. It will. It has all. Okay, we are ready again. Sorry for the delay. Prashant, please reconfigure again. Okay. So now.
Is it in good condition?
Everything is ready, Prashant?
Is it in good condition?
Yeah, sir, it is good.
Oh, go ahead.
Actually, sir, we are okay with the drift also. So no worries. Prashant, ready? Muskan, ready? Okay, we are taking off in. Okay. You can down the throttle. We are good. It will just arm in any moment. It is arming and take off in any moment. Okay, again reconfiguring everything. Muskan, raise the RC. It is traversing autonomously right now. Telemetry feed can be verified again. Okay, it has found the bottom part of the arena, so it is detected that. Now moving left for the 2 seconds at 0.2 meters. Now forward. Healthy, I guess. Prashant, bring the propellers. Sir, we'll just take hardly 4 to 5 minutes. Also, bring the Allen keys. सब कुछ ठीक है? वेरीफाई कर लो. स्मेल है? I request the management to please turn the light above because it is reflecting. So it is in the it detected the yellow line here. Can you please turn? Yes, sir. Sir, actually it is reflecting, so that's why it doesn't detect a yellow color. So the light's above, just above it.
Only this line.
Yeah, these ones are last ones. Last 2 rows, please turn off. We are healthy and we'll good to go again. Yeah, please. Just bring it quickly.
वो तो मेरा है.
We cannot start from the home position. Why you want to? So what you want to demonstrate now? Actually now, you will be able to do autonomously more than one point. So will you be able to autonomously go to more than one point? That's what is required, correct now? When you landed, no, I understood. Now what you want to show, you can just. Okay, go ahead, please. Yeah. Okay, go ahead. Yeah. Okay, is it okay? It's in proper. Okay. Yeah, slowly you do it.
Thank you. ग्लेयर मारा बहुत ज़्यादा, फिर ऐसा हो कि वो येलो से आगे निकल गया, फिर वो बॉटम पार्ट में डिटेक्ट करने लगा, तो वो वही ऐसे ऐसे हो गया। अच्छा इससे कनेक्टेड है। एक मिनट लेट हो जाएगा, आराम से यही लगेगा, कोई ना। हाँ आ रहा है, वो एरर नहीं, मैं अभी okay, sir, we are good to go again. Sir, what just we did now, actually, due to the glare, maybe the system has detected the, like, it needs a power cycle after a crash. So that was a crash actually. So we need a power cycle. So we just did that, and we just kept the drone again. Now it is ready to fly again.
It showed some lidar fail or something.
Yes, sir.
Okay, okay, that's
so actually lidar fail was happen only when the, because when lidar fail, drone can't fly anyway. So that is a sign of power cycle. So we just did that.
Just one question. You did power cycling, so at the last it will be able to go to the home position?
Sir, as I said, we didn't do any coordinate system here. Our drone is completely real time, and if you say wherever we just kept the drone there only. It can start the mission there from there also.
No, her point is where it will return back finally. What are you?
Sir, there only. Sir, in a single shot, it will return here only. If we will start the mission again, from now home is for it there only.
Okay, okay. From here you'll show. Okay.
Yeah. If you want, we can. Okay,
go ahead.
Okay.
Go ahead. Continue.
Prashant, ready? Okay.
But now only 2 more staff it has to do. If you do 3, I don't know where it is.
No, that will be wrong. Okay. That will be fine.
Sir, actually, so much of light was coming, na? So due to reflection. Sir, actually, it was the natural light. There is the ambient light of there also. So Yes, sir. This is sir actually. Nothing, sir. This is good now. Okay. Prashant, ready? Okay, we are ready. We'll just take off in a moment. Just start the mission. In 3, 2, 1, enter. Okay. Now connecting. Everything is okay. Calm down, okay? We'll do this. Okay. It is booting up, sir. Okay, cable is disconnected, I guess. किसके? Connecting again. So you can see the localization also there. Arming the motors. Armed again. Taking off. Healthy now. Coming forward. Muskan, raise the RC. Raise the RC. It is scanning bottom and going bottom, okay. Sir, we had an error, I guess. Just kill. I guess we had an error actually, so we should restart, I guess.
Was it manually intervened? Okay. Now, how it came back to this position actually? Okay. Karthik, another 15 minutes only we have. You just correct now. Eh? Okay, they can. Okay. Okay, go ahead, go ahead, go ahead, go ahead. We have less time now. Go ahead. Another 10 minutes. After that, select and go. Next week. Everything is ready? Okay, we can arrange this better. That's all.
We are ready.
Okay.
Please make sure the lights won't turn off mid-flight. It has took off again. Booting up the camera. Sir, this was autonomous fail-safe. Sir, maybe the camera hasn't booted up due to last crash. Why?
Karthik, you okay? You do it and tell what you want to do. It, Alex. Karthik, okay, you have very less time now. Okay, 10 minutes. 10 minutes we have. Okay.
Disarm switch is on. Ready to arm again.
Okay.
Fine.
Starting code.
Okay. Start the mission. Okay, we are doing again.
Okay, connecting to vehicle.
Connecting again.
Karthik, the question is battery, is it charged?
Yeah.
It is charged, sir. We had a good flight time, sir.
Okay. Now what you are going to show? Same. Autonomous.
Sir. Yes, sir. Completely autonomous, sir.
Okay. The camera is okay now? Can we get
sir,
in?
I just reboot it again.
Okay.
Let's see.
So, okay. Are you
guided?
Guided mode. Again.
Yes.
Okay, started. Connecting.
Connecting again. Throttle is down.
Okay,
arming again.
Armed.
Taking off.
Altitude reached.
Okay, now camera is again booted up. Finally.
Scanning bottom. Scanning. Okay. Scanning bottom, scanning. Scanning.
It is good. Good.
Yeah. Scanning bottom. Detected.
Found.
Detected. It is detected.
Now.
Yellow line detected. Moving forward. Okay. Safe spot detected and landing. Okay. Okay.
It was completely autonomous. The
Very
second
good.
spot has landed as you see. Now, from there, can we move to the third spot again, sir?
Yeah.
Okay,
good,
please
good.
start quickly.
Okay.
No, is it not autonomous? Okay. Let
Sir,
it
it was
go.
completely autonomous.
Okay,
sir.
good, 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 good. Please, go ahead. Yeah.
Starting. Connecting to vehicle. Disarm switch.
Yeah.
Muskan.
Allow the drone to fly again. Okay. Yes.
Disarm switch is on.
Oh, it will update now. Just 2 seconds. Wait now. Okay, it is good.
Okay. Okay. Okay.
Hello.
Okay. Okay.
Muskan, I'll guide you. Don't worry.
Connecting.
I'll guide. Yeah. Ready?
Yeah. Connecting.
Now again it will take off again from that same heading.
Okay.
We didn't alter anything now.
Armed.
Armed, taking off at any moment. Yeah.
Good.
Reaching altitude. Altitude reached. Moving forward.
Camera is on, as you see. Camera is now turning on. Now, camera is on.
Scanning bottom. It is going backwards. Okay, scanning. 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 Not detected yet. Detected. Detected. Not detected. Take the manual mode. Yeah. Command has been taken. Manual. Now
Land
it is
immediately
manual.
at the same position.
Okay.
Just restart the mission quickly. Muskan, allow the drone.
Okay, okay.
Okay, restart mission again. Okay, restart mission again, please.
Okay. Starting mission. Connecting
Connecting
to
again.
vehicle. Connecting.
Prashant, I'll guide. Just stop. I'll guide. Muskan, I'll guide you. I'll tell when if it's not you have to do just. The battery is good. It is arming. In any moment.
Arming.
It is arming now. It is
Reaching
armed,
altitude.
Took off.
Moving backward. Backward.
Scanning bottom.
Scanning.
Found it.
Scanned. Scanned.
Found it. Prashant, I'll guide now. Don't worry. Just to stop it. Scanning photo front. Scanning, scanning, scanning.
Moving forward.
Scanning front, scanning. Scanning front. Scanning front. Scanning front. Scanning front. Just put the RC up. Maybe it has found the spot and landed. Good, good, good.
Very good.
Disarm it. Okay, sir.
Okay,
Now
good.
your questions, please, sir.
Good, good.
Yes, sir. Sir, where, sir? Sir, at that moment, the land immediation was there because, sir, actually, the base master has run the wrong script, actually, run the wrong code. So it was a testing code.
Okay, Karthik, further anything? That's all? Over? Your demonstration is over now?
Sir, home position we can maybe stretch.
Yeah. Yeah, yeah.
Yes, sir. Sir, maybe, sir, sir.
Okay. Okay, Karthik, you can.
Yes, sir. I can tell, sir. Actually, we have tested around so many times in the in college. Actually, so what happened here is,
can go to home.
sir, when it like
Yeah.
reconfigure from 2 positions.
Okay.
So,
Karthik, can you go to home position and?
yes, sir. We are okay.
Good, good.
Just need a permission, sir.
Go ahead, go ahead.
Okay.
Whatever he is telling, I think.
Just please go quickly.
He is telling to him, scan for the don't stop.
Karthik, go ahead. Here, this other RC is not operated, correct? No?
You can see it is down.
Oh, fine, fine, fine. From the computer also. Okay, you are also
Just
seeing.
here
No,
also.
go ahead now.
Your IMA should
Oh, just give us the
Reaching back to home position.
Okay. Sorry. Okay, we are ready. Prashant, ready? Muskan, ready? Okay, we are going to the home as the mission is completed. And this is the, sorry, can I show this if you want? Right now or after mission only? Okay, start the mission. I'll tell you. Prashant, I'll guide, don't worry. I'll guide. Yeah. It is good. Okay. Connecting. It will just take off in any moment. And again scan the home position and move towards that. Sir, here, according to that, because as you have seen that, took off. The camera is opening. Now camera is opened. Scan bottom. Because last one was bottom only, so it is continue the bottom. Now going, as you see that, sir, the localization also working fine here. It is also working fine here, sir. The path is also, the complete path is here.
No, is it going to third spot or home position?
Sir, according to it, home is here, as I have
Okay.
mentioned, because we have done the power cycle here.
Okay. What is it?
Yes, sir.
Why it is taking like that route instead of direct?
Sir, actually it is, sir, we have our own navigation. It works on, actually, errors only. It works on errors only. Actually, drift only.
No, is it
remove the
because-
drift and move according to that. Actually, again, I guess the same issue as
Go to home position, isn't it? No, what was the real intention? It has to come to this position. No safe detection, correct? No, it was not intending to detect any safe point, isn't it? It was only intending to coming to home point, isn't it? What was this last task?
Sir, as I said that we did a power cycle here.
Okay.
So according to it, like the home is here.
Okay, okay. No, why it went there only, we are trying to find out.
Sir, actually the same issue. Can I put the doors off, please?
Doors.
Huh?
No,
Okay.
door we can close, not a problem.
Sir, actually that is the ambient light.
No, no,
This is the.
It's okay, we can close, ask them to close. Door you want to close?
Yes, sir. So actually
No, no,
the light
can-
is coming. Sunlight is coming, sir.
Sir, can we close the door? Just. Yeah, yeah.
Sir, I had told because, sir, as I said that we had a navigation.
Okay, door
of
is closed
algorithm
now. Karthik.
That works on drift.
Closed. You want to start now? Only last attempt.
Okay, start again mission, please. Start the mission. So we'll answer the questions after the
So,
mission.
Karthik, this is the only last attempt. Anyway, we have short of time now. Just go ahead, please.
Sure, sir. Uh-huh. Put it there, na? Last.
He's not agreeing for that. I also asked him.
Sir, I guess the time is short, sir. You can ask the questions, and I guess.
No, questions are over. Done. No, it's over. Over is okay. No problem. Karthik.
Sir?
No.
Sir, drone is very healthy, sir. You can perform the task.
No,
But,
no.
sir,
If
the
you are
question
ready,
will
we
miss,
can
sir.
do. If it's
Yes,
over,
sir.
we can close. No issue.
Okay, sir.
Okay, that's it.
Okay, start. Okay, mission started. It is connecting now.
Yeah, yeah. Already max.
it is taking off in just a moment. It is just took off. Just wait, kept raising hand. The secondary RC here, sir. It know the mission, it will complete it.
Router over.
The telemetry is gone due to the router. It knows the mission, I guess. Just land again. No, land. Leave it. Okay. Down. Land it at a home position. Again land. Just land it. Sir, autonomous landing again.
Okay, Karthik, good. It's real good work. Nicely it landed.
Thank you so much, sir. Thank you so much, sir. Thank you so much, sir. Thank you,
Good,
sir.
nice. Very good.
Sir,
Nicely also you explained very nicely. It's good.
Sir, we had
Nice.
to, sir, like we have, my team has worked tirelessly on one thing. We want to show, please, just give us 2 minutes. We can just show the
For
stability.
which one? For which?
Sir, we want to show the stability of our drone, sir. Can we show this, please? Sir, we have worked tirelessly on that,
No,
sir.
it was very good. Now, what you want to show, I didn't understand.
Sir, actually, we had worked on what if a system has manually intervened in mid-flight, what if it is flying here, and I will just took here, and it will again go to the position where it was. Sir, please allow us the time. It is 2 minutes, sir. Please, sir.
How much time will take? For
Sir, only 2 minutes, sir. Just 2 minutes,
2
sir.
minutes
Please
starts
allow, sir.
now. Okay.
No,
Okay,
sir.
Karthik,
As I
anyway,
said that.
this is not part of that thing. You go ahead quickly and.
Sir, we just want to show that, sir. So actually, we have worked very hard on that, sir.
Karthik, just one,
Parallelly, somebody should.
one doubt here, whether GPS are you using?
No, sir. Sir, as you, sir, in the recording, you can see here is no GPS sign was there. Secondly, sir. Yeah, definitely. Sir, you can see the recording, sir. It is there, sir. You can see the no GPS, sir. I guess you have read that. Sir, I want to tell the truth. My team doesn't know how to fly on GPS also. From the day one, we did on the non-GPS mode only. So we had an idea that, okay, we had a crash because of drift, so just use this drift as a weapon to navigate again. So, Prashant, go there, na?
Actually, I want to tell the committee that we started this competition. Actually, we learned throughout the competition. I did not know how to fly a drone. Basically, from the crashes, we had crashes every single day. And slowly and steadily, our team built an app which is capable of stable, hovering, then slowly detection. Here, that our detection was working quite fine when we were working on our arena. Here, some glare issues there. Otherwise, it would have not been a problem if the glare was not there.
Actually, it was a very good performance. Don't
It is opening, sir. You
good,
can see the
excellent.
GPS also, sir.
It could be better, sir, because we have seen
Always,
it
definitely.
performing.
Don't worry.
Prashant?
Opening. The telemetry opening.
Sir, you can see there is no GPS.
Okay. Connected. Okay. So this is the open source terminal.
Ardu pilot.
It is connecting here. Leveling connecting.
Sir, okay.
Try again.
There is no GPS. You can see.
Okay, let's connect first. Huh? Okay, connected. Yeah, it is connected now. Here, just expand it now, sir. No GPS here. Yes, sir. Sir, okay, okay. Sir, I will confirm it.
It will pay path also.
Confirm,
it
sir?
will move like it will move.
I guess it is confirmed, sir.
You can move also there with path also.
Yeah. Please, okay.
Prashant, zoom in for the path.
I am moving it in
Okay.
the arena, and it is
So
live.
the
Okay.
live, it
Okay.
is
This
path.
the thing I want to show that, please. Can we continue, sir? Okay. Prashant. Muskan, to the loiter mode.
Yeah, something you want to show?
Yes, sir. Just 2 minutes only. Sir, actually my team has worked.
Very well. Don't worry. Good.
Sir, actually my team has worked on that thing very well. So it is apart from the task I know, but that could go betterment of some other thing. Yeah, yeah. Please, Muskan, come here, no? Inside the arena. Here only. Soon, take off it here only. Okay, I'll show the task. What the task is? We'll took off from around 1 meter altitude. I'll just alter it to here, and you can see it just go again there. Sorry, sir. Be ready. Take off. Manual take off. It is stable now. I'll alter mid-flight. So this was we want to show because this thing we have worked tirelessly on this. Sir, again it come to the same position. Again. Muskan, can you down the RC? Just put it down now. Again I have to show. So this was done by the team. This is the team Surya signing off. Thank you.
Thanks, Karthik.
Just roll up.
For this extra task, 2 marks already.
Surya. Surya, it's good, I think. Yeah, it was good actually. Yes, just a minute.
due to the lighting issue. That's the first attempt. In the second attempt, it was about to go into the net, he thought. So he intervened manually. And what happened was when we were returning in the manual landing, it made a power landing, due to which the camera actually lodged out of the mount. Yeah, camera lodged out of the mount. It was not a software issue. It was just a hardware failure.
Okay, Bill. No, it was the same camera. What happened is, yeah, it had actually tilted in the second run, so it had not seen the boundary. No other change. We're rerunning it as is. Yes. No, it's taken care of. This was the config. The second, I don't know, actually manually intervened. It had, just after I stopped it, it recognized the boundary. So that setting is. Sorry. Yeah, 1 second later, from there I thought I was going to.
I detected the 3 boundaries perfectly. The fourth one just we thought error. Yes. Yes, sir. Yes, thank you. Right, we are ready to begin. Rishabh, go ahead. Just 3 to 1. Sir. Done? 3 to 1? Ah,
Are you ready? Ready fully? Yeah. Good. Lighting is okay for you?
Yes, sir. Yes.
All the lighting is fine. Okay, fine.
Athar, lighting good? Rishabh? Yeah. Ashutosh? Udhar जा, वो next. तुझे जा. Okay, sir, we are beginning.
Yeah, go ahead.
Yes, sir. 3, 2, 1, do it. Started. Fully autonomous. 3.5 meters. Boundary sequence started. Going forward. Ashutosh. Rishabh. Identified the boundary. Going back. Ashutosh. Identified the back boundary. Now going, hovering over the home position for a second and we'll go to the right. Identified the right boundary, we'll go left. Very good. Okay. Left boundary detected. So the arena boundary has been completely detected. Okay, no issue. Okay. No. Okay, so the arena boundary has been completely mapped. That was perfectly autonomous.
Okay.
We just replaced the battery quickly.
What was the issue? Battery, what happened?
Yes, sir. Actually, the battery failsafe got kicked in. So, yeah.
Okay.
Resuming in just a minute, sir. Okay, बता देता हूँ. That I have to see, sir. I don't know. I'll see and tell you, sir. Sir, resuming again with a new battery.
Who is that? Team Rudra, can you say what you're going to do now? This is the last attempt now. We have.
Sir, we are doing the full task.
No, means again it will go for scanning and come back or what?
Yes, sir. But we have the partially identified map from this attempt. So
Okay,
we'll attempt
okay.
the entire thing again, just one time. It's fine. Do it. All ready? All set? Propeller is not an issue now. Propeller is not an issue now. Chalo, quick. Give me 3 to 1.
Correct. Scanning plus landing. No, actual operation.
अनप्लग कर वापस रुक जा
Okay, another 2-3 minutes. You are ready with your. Ashutosh, can we go ahead? Can we?
That is done now. इसको हुआ क्रैश
चलो
क्रैश तो क्रैश नहीं चालू नहीं हो रहा है चालू ही नहीं है तूने ड्रोन मर गया मत ओके नहीं करना चालू ही नहीं हो रहा बैटरी रिप्लेस करो वापस देखिए छोड़ दे ओके मैं बोल देता हूँ
Okay, sir, we are unable to do it. We'll show you the map generated and the data.
क्रैश में डैमेज हो गया ऑन ही नहीं हो रहा
They reported
they have
its damage during this crash.
Sorry?
They reported that this crash, I mean during crash it got damaged.
Okay, good. Already you have taken. Good efforts. Very good. It's okay, anyway, we sufficient. We'll see later, no issue. Oh, that's a good thing. Okay, good. Very good. Nice.
हो गया ना दूसरा देखा
Okay, good. You just show other numbers or some other. Yeah. Could have. Did it direct any save point?
Example map, he is taking out the PCD from
Okay. Okay, very good. Nice. It's good. So the other team can come.
हेलो
Team Rudra, no? You just explain.
So our detection algorithm is work like when the PCD file that is generated from the drone mapping, what we do is we use it to find out the gradient elevation.
So essentially after scanning it creates a 3D point cloud and now this 3D point cloud we use the altitude to create a digital elevation map. So that essentially it's a grid of what are the maximum altitudes in grid cells. So it creates something like this. And then what we do is we take the gradient of the arena and the gradient will essentially tell us the height change.
Is it in meter? Okay.
No, we're just showing you the algorithm output. So this one we have to download.
We have to download it, but it is generated.
Yeah, it is generated, we'll download it and show you. Yeah, but I'm just explaining how the algorithm works. This, and then what we do, it takes the gradient of x and y, and then essentially we get which areas have more height change and less height change. And then we take a circular filter of 1.2 meter diameter and pass it over and convolve it over the entire map to identify which regions have the minimum change, and that is corresponds to the flattest spots. So you have this data from which sensor? We have the this is an Intel RealSense depth camera. Yeah, we're using this for VIO as well as the mapping process. And this is put at an angle of 25 degrees, so it's a balance between getting full resolution of the scan and having some visual odometry features to track. Yes, so this is the HolyBro H-flow sensor. It has a 30-meter range. So this is used for rangefinder. This has the rangefinder, and this is the optic flow. Yes. No, so this is just a single point LiDAR. So it will, let's say, if you have this paper, it will only at this very specific point. If we want to use only that to cover the entire arena, it will take a lot of time. It has to every minuscules. So this one has a 2D LiDAR. So it scans the entire image at once. So this is used for mapping. This is purely for maintaining altitude of the ANAV.
This your thing will start from, if you change the position, is it okay for you?
Can we explain novelty?
Or is it the position or direction if you change?
That time the battery failsafe kicked in, so it started coming down.
Now
Yes, it was
it's
coming
way-
down, but then the battery was low, so it was losing thrust. So we're
No.
losing some control authority.
Take off
So
from any place.
it was a little unstable during the landing.
Semi-autonomous. Just now we declared it autonomous.
Yeah, that's what we want to
So
know. If you,
one
if
main
you
issue
change the
even
position,
during
is it okay
testing
for
we
you?
encountered is when we keep it on the ground, even during
Yeah,
initial
yeah.
launch and when landing at safe spots. What happens is between that time, because there are not a lot of features, when you're very close to the ground, the optic flow starts drifting. So that's why if you notice, every time right before we launch, we restart the vehicle, so it's reset to 0, 0. Because otherwise the readings drift and then that propagates to the other safe spots when you're performing.
This was kept long because of the problem which we faced in the arena which we built in our college.
Yeah, so we were actually had smaller legs before. We upgraded them to taller legs now. No, after the crash, the flight controller was not starting up, so we'll have to see.
Flight controller is not starting.
Yeah.
But explain the novelty this.
Yeah. So initially,
So what we were seeing in the morning, all the things. So he has actually designed it, all built it. So he'll explain it better. Yeah. All the 3D printed.
So obviously for 15 degrees directly we can't land. Even if you land very slow, there's a very high chance this will tend to tip over. So what we had built, this is a actuated landing gear. So this is a servo motor, and the idea is this is mounted here. And let's say when you're landing at a 15 degree spot, right before we land, this can extend out. Yeah. And this extends out and can add some height on any one of the sides. So there are two on each of these. We mainly did not use this due to weight constraints those passing. Yeah. So no, we did not have it now. So instead, what we did to give some additional support during landing, we added this landing. This is inspired by helicopters. If you have seen, they have this thing. So we made this is purely passive. So this helps at least even in sloped landings. Even if the safe spots aren't perfectly flat, this at least helps give it more, makes it stable. Right. And we also developed a custom vibration. This is custom design, and we 3D printed this. It's a custom vibration isolation system. So initial development, when we were developing, it was hard mounted, and it would tend once we hit a certain RPM due to vibration, the drone would suddenly think it's upside down. It would just flip. So we then designed this custom vibration isolation top plate. Yes. So we looked at the. Do you have that? Okay. Okay. So the acceleration, the vibration is measured. This has sensors to measure vibration. So initially, when it was hard mounted, we were seeing vibrations around 12 meters per second square throughout, and it was very spread out. If you look at when you plot it. Yes. So the IMU gyroscope is inside the flight controller here in the orange, and after this, we have it under 4 meters per second square.
Other team is ready. Okay, just Sky Sovereign, you are ready now?
Okay.
Sky Sovereign team, no? You are ready now?
Okay, thank you.
Okay.
So there is a change we have done.
Okay, you explain that.
Yeah, there is a change we have done. Previously, we had used the fully autonomous code, but now it's semi-autonomous because that code is not actually working. So now what we have done is the scanning pattern we have fed. The scanning will be done by some set points, since that was the starting point, which we used for elimination round, and so
The starting point.
According to that, we'll be doing the scanning.
Okay, and
then it will
only scanning point is starting is stored and scanning is stored.
Scanning stored, and then it will store the flat areas.
Okay, will it detect your periphery also?
Yes, it will.
Okay, and identify the safe points?
Yeah.
Land. Okay, go ahead with what?
So it is more of like you have fed the home position input to the relative to boundary, right?
it rotates, not into problem. Okay.
So this was it had started capturing after that it went down, battery got low. So midway it's gone, so the bottom of the coordinates of that coordinates reference into the axis of the flying. This is the only cloud complex, so you can see this is the altitude elevation. This was straight up. And yes, this is high. 15 degrees line. And it is a plus sign because it was going straight up. But the moment you come here, you need to back it up. So after the boundary finish, we noticed it started going because it had calculated during boundary. So this is the PCD point cloud. So here is the 15 degree one. So this is that elevation map which we created from this. It actually started this area, it started exploring, but then we got
we want to show it manually. We want to show it manual. Manual takeoff will show the scanning.
Okay, Team Severin has completed their assignments. Okay, it's a good performance, it's good work. Nice. All the best. Okay, okay.
tell what went wrong here today? Yes. What went wrong today?
Actually, in the first time, our takeoff node was not working. It was not taking the takeoff command, although it was working while we were testing with our arena back at our university. But now, and I thought we would use the code which we used in the elimination round, and so but still it's yawing. Actually, it should not yaw. It should just it should have the same position and then take off. But there is a yaw, which may be due to some internet.
It's like initially we have tested out here today. Yesterday we have tested this out. The first autonomous flight we have taken out. In that autonomous flight it was yawing out in the first try, just like you saw now. So after that we did some tweaks into the flight controller, and inside the flight controller there was some internal IMU damage. So we were like trying to resolve that issue. At that time it got resolved, and it was doing the autonomous takeoff, and we did single hop and double hop. But currently now, as we shifted back to the previous code, like currently we tried with the new code in the first try, but as we tried in the second code, the yawing occurred again. So it was like the internal IMU failure. That's like the PIXOC 6x that we incorporated, maybe there was some damage inside due to the crash initially we had in our college, because there was a major crash. It was landed up in the top position, and one of our junior, like while controlling out in the remote control mode, instead of land mode, he clicked on the manual mode, and the drone, to control and to stabilize it out, it moved to the highest position. It got tracked to the ceiling. So in that, maybe some damage occurred in that. We're so sorry for that.
It's okay.
Okay, you can move for photo. Okay, thank you, sir.
Team Martians, the last contender. So you have to pick up a position from here. That is for the position, and this is for the heading angle. Okay, whichever is there, you can just pick. Okay. Correct. Just read it out. So position 3, west direction. Position 3 and west. Is okay for you? Any position?
No,
just
sir.
Let them just see.
Okay, sir.
So position 3. So you know about the competition requirements, isn't it?
Yes, sir.
From the home position, you have to go up, scan for the safe spots autonomously, and land into each of the safe spots and reach back to the home position.
Yes,
That's
sir.
the primary
Yes, sir.
objective.
Yes, sir.
And it has to be done autonomously is the primary
Sure, sir.
objective.
Sure, sir.
And the periphery is marked with the yellow color. That's also you are aware, correct?
Yes,
no?
sir.
So in case of any emergency or safety requirements, you can always use the RC and then take control and inform it, okay?
Yes, sir.
And you are expected to do autonomously, but in case you find it difficult, you can scan it and then make the computer identify it autonomously. It's safe. spots autonomously. That
Okay.
also carries
Okay.
some weightage. Okay,
Sure,
that is one thing. In case you have a position issue or something, illumination issue, you can tell.
Okay.
We can modify. Okay.
Okay.
Just right now you have selected position 1, position 3 west looking. Okay. West means it will be starting from this direction. Okay.
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 So you are ready to do autonomously, or which way you are
Yes,
able
sir.
to do?
Yes.
Okay. You are ready with your system?
Yes, sir.
Fine, fine. Go ahead with setting up and quickly come to the actual.
Okay.
So
Okay.
if somebody can brief the configuration, you can do it. Meanwhile, others can start setting it up. Okay.
Sure, sir. Drone layout. Good afternoon, judges. I am Vaibhav Arya, the team lead of the Martian from Kite Group of Institutions, Ghaziabad. Sir, we have modified the drone. This UAV is configured to considering all the guidelines of IROC 2025. Sir, I am an embedded system lead, hardware plus software. So I would like to brief you about all the hardware parts and why we use it. Sir, first, as a sensing unit, we use Intel Depth Camera 4735 to detect the safe spot. Plus, we also use MF01 micro air optical flow sensor to determine the X and Y position and rangefinder values. Sir, in place of flight controller, we use Pixof Cube Orange Plus instead of Pixof Cube, as it have 3 IMUs, which gives high stability. So we don't need to connect another compass in it. So to detect the safe spot, we use Intel Depth Cam, as we use variance method. In this method, the drone navigate in the arena and detect which area have the minimum variance and then land it. And
so if you want to keep the plan the setup, go ahead with that.
Sure,
Okay.
sir.
It's okay. It's good. You can continue explanation, one of you, or if you are required, you can ask somebody to explain. No issue.
No, sir. No, sir.
Just, yeah.
To brief you about the navigation part, I would like to call our navigation lead, Harvansh Jadhav.
Good afternoon, gentlemen. So for navigation purpose, we are using Visual Slam, and with the Visual Slam is not, we are not only using Visual Slam because it is if we lost the odometry, then it is impossible to guide the drone in autonomous navigation. So we have also used fused the optical flow sensors to make the precise navigations throughout the arena. So how it is working? First of all, the drone will take off the flight up to a altitude of 1.5 to 2 meters, and then it will take a forward movement to detect the first boundary. Then it will return to its original home position, launching position, then return to the right position, right boundary, and configure the arena. Now this virtual arena, with the help of RTMap and RViz, this virtual arena will be imposed on the real world arena, so that whatever will be the execution happening in the real world by the drone can be easily visualized in the RViz, and the commands can be given to the drone autonomously as per the requirement, as per the navigation. And for the precision and accuracy purpose, we have also created our own PID control system within the script with the help of programming, so that if the trajectory of the drone drifts a little bit from its original path, then it will auto-correct it with the help of script and send the commands to the Pixoc to maintain the same trajectory throughout the journey.
With the help of a script, which one you tell? With the help of?
Sir, we have created a script within our whole execution plan, in which it detects how the actual path is drifted from the current path of the drone.
That is from some other sensor.
Yes, sir. With the help of RViz, we can identify what kind of drift we are experiencing in the autonomous navigation. Okay. So after the detection, the whole system sends the command to the Pixoc to auto-correct it and keep it on the same trajectory. After all, for the border detection, we have fused a long range of values of HSV values and other values to detect the yellow border perfectly. So if the lighting conditions are not proper, if there is a different variations of yellow yellow colors, then it can efficiently detect the yellow boundary and will always keep himself within the arena for the safety purposes and effective navigation. So this is whole plan about the navigation. For algorithm purpose, we are using DFS, which is one of the prominent based on the frontier approach, so that the execution time will be minimized, covering all the safe spots, landing, and complete execution of the task. This is all from my side, sir.
Okay, good.
Good afternoon. I am going to tell you about the safe zone detection. For the planar surfaces, we are using the concept of variance. Like if we are spotting a cell, we will check the depth and the depth of the neighbor cells. If the depth is somewhat similar and comparable, we consider that the variance is low, and we mark that region as a safe zone. But to further enhance the approach, we have also used the geometric constraint. Like if the area of the if the area of low variance is somewhat similar to the area of the safe zone, then that area will be ultimately marked as the safe zone. So for the further approach, I would like to
Good afternoon, judges. So I worked on boundary detection. As Harvansh already told you, we have used a large values of HSV ranges for yellow color detection mainly. Further, I helped with him for safe spot detection. So we were using, as he told, low variance areas mainly, because planar surfaces already will have lower areas in a certain amount of area that it will give for detection mainly. So, yeah.
Okay, good. So you are planning to demonstrate autonomously to detect, will it scan or first detect the peripheries and go for mapping or scan? What is the plan now?
So the execution plan, first of all, it will initialize the whole arena by detecting the forward boundary and the rightmost boundary. After the initialization of the arena, it will implement the DFS algorithm to traverse each and every part of the arena. During the navigation, if it finds any safe spot, then it will detect it quickly and goes to the landing command, land safely, then again it will take off, go to the original execution mode, and will traverse the whole path.
So first it will map and then go for
exactly, sir. Simultaneously, it will also create a 3D map cloud, which can be also used for the visualization purposes and safe spot detection. Sir, if you like us to, then we can manually demonstrate how the arena initialization is working, how the DFS is working, because during the execution time, it will not be possible to show through the terminal outputs. It will show some lag.
Okay, you are ready with that? Then you can go ahead. In case you find some difficulty, you want to go manual or not, you decide.
Okay, sir. Okay. Definitely, sir.
Are you ready now?
Yes, sir. Yes, sir. Thank you, sir. Thank you, gentlemen.
Just one clarification. This first you are doing mapping, scanning, or you are identifying the spot, you are going down, then you are going for safe?
Yes, sir. First of all, we are initializing the arena. Like we will go forward extreme until we didn't find a safe yellow boundary. Then we will return back to the original launching position. Then we move towards the right position extreme until we didn't find the yellow boundary. In this way, we already know what are the dimensions of the arena. So with the help of these exactly two movements, we didn't require a redundant movements of the drone. So with only these two proper movements, we can already initialize the complete arena, and that complete arena will be superimposed on the real environment, so that the navigation that is happening in the virtual environment, virtual world, will be same as the execution in the real world. So this is how it will help to save the time, execution time, and save the power, and become effective navigation for the whole execution plan.
Please go ahead.
Yes, sir. Thank you, sir. चीज रेडी क्यों नहीं करी तब से? हम वेट कर रहे थे, तब से रेडी क्यों नहीं करी? नहीं, वो दिक्कत हो रहा, कनेक्ट हो रहा था, स्टार्ट को कॉल कर। चलो गाइस, ऐसे नहीं करने का, जो होगा सो होगा, टेक अ चिल। बैटरी चार्जिंग लगी है ना सारी? Connected. Martians and DFS. Last underscore DFS नहीं last. Last underscore DFS. Dot DFS. Okay. ठीक है. तो अभी एंटर दबाना है, बस बैक दे दो. Judges, we are good to go with the execution. If you allow us, we can execute. Thank you. Now you can run. Okay, everything goes fine till now, and the autonomous execution script has been started. The drone goes into the arm mode, and it is launching some of the required nodes for the precision navigation and sensor requirements. The drone will hover for about 10 to 15 seconds to initialize all nodes and other requirements. Now it is moving forward to detect the first yellow boundary so that it can effectively initialize the arena. No. Take manual control. Right. I think lightning conditions are creating some chaos to detect the yellow arena.
Manual control has been taken.
Now we are in the manual control, sir.
Okay.
Sir, if you allow, then we can check whether, because lighting condition may affect the boundary detection. If you allow, then we can check.
Yeah, quickly.
Whatever really suit. Okay, thank you, sir.
More lighting or less?
Sir, I think we want, let us check, let us give 2
So
minutes.
if you want some other question also you decide, instead of that you start from some other place.
No, sir, let us check the, first of all, let's check the yellow boundary detection.
You come this side, don't block it. Okay. Slightly you can turn it towards you, but you ensure that display is here. Fine? You can sit actually. You can sit around.
हाँ चलिए अभी तो वहाँ रखा है. Sorry for the inconvenience, jury. The lighting conditions are the reason. So we have now the yellow border detection is working properly. Now we are again executing the task. सारी रेडी करो. So the execution has started again. It has gone into the launch command. The boundary is detected successfully and it is initializing the arena for the DFS algorithm. Take manual control fast. Take manual control, Gar.
Manually controlled.
Yes, sir. So we think due to insufficient lighting condition that it is unable to detect the yellow boundary properly. Like it has first of all detected the left-rightmost boundary and reflect its trajectory to maintain within the arena, but forward boundaries are not still detecting. If possible, we can have some more lights. Vertically, down. Vertical lights. Okay, sir. What, sir?
This yellow line.
Yes, sir.
Simulated outside. No? Was it detecting?
Yes, sir. Like the rightmost boundaries was successfully detected, and it has.
It has detected. You better switch off all these lights.
Okay, sir. Let us try. Let us try with switch off lighting. Okay, sir. Okay, sir. Okay, sir. Thank you, sir. Sir, we can try switch off. Okay, okay. Let us try this. Thank you, sir.
तो येलो डिटेक्टर प्रीवाइड ऑन करने में ना
The difference. Now you can verify your camera all around. Hold in hand.
हाथ से कैपिटल है एम कैपिटल अरे @ मत कीजिए कौन डालेगा
You got to take one more signature is pending, right? Both are done. Both are done. Good.
एक मिनट दिखा दो ना मैं लिखा के मैं दिखा दूँ
Detected.
अच्छे से काम नहीं कर रहा
Detected. 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 Go on. Detected. Go on.
हाँ डिटेक्ट कर रहा है
ऊपर
चलो हाँ हाँ
Clean, right?
Yes.
Detecting. It is detecting. Those are the lights which are reflecting back.
Okay.
Exactly. Reflection. Perfect.
देख स्क्रिप्ट खुली है शायद नहीं नहीं खुली है फाइनल अंडरस्कोर 6 अंडरस्कोर फिक्स नहीं है सॉरी लास्ट ईयर
वाइट हो गया था
सेल्स व्हाट है ये फेस व्हाट है
येलो का येलो थ्रेशोल्ड 3.5 होना चाहिए
अब तक रोटेट टू 3.5 0.35
और इसमें वो कहाँ है येलो डायरेक्शन थ्रेशोल्ड
हाँ पूरा कर रहा था
Jury, we have made some modification in the script. Now we are again trying with this lighting condition. Let us hope that it detect the yellow boundary.
No, is this lighting okay, or you need to do something? They have switched off the.
No, sir. Is this lighting? This lighting is working. It is detecting the yellow border arena. Now let us try through the autonomous navigation.
Okay.
Run करो सारा. हाँ, execute. Autonomous navigation has been activated. Now it will take off. Garv armed. The drone has been armed successfully. Now it is initializing some of the nodes with proper stability. It is maintaining the altitude of around 2 meters from the ground level. Now it is moving in a particular direction to identify the boundary. Yes, arena, manual control. Okay, no, sir.
Manually control.
Jury, sorry for the inconvenience, but I think the yellow border lighting conditions are making chaos for us.
Okay.
Yes, sir.
You have any manual way of scanning and identifying the safe spots?
Yes, sir. We can do this manually. Like we can demonstrate the DFS navigation, how manually it is initializing the arena, and after it implements the DFS. If you allow us, then we can do that.
Yeah, go ahead. For that, whatever lighting is there, you make it up.
Okay.
This, if you want to switch up, and quickly go ahead.
Okay. Thank you, sir. Yes, sir. We have increased the threshold, but it is still not detecting the yellow border. We have increased the threshold detection from 20% to 50%, but it is not detecting the yellow arena. Like in the outdoor condition, it was perfectly detecting the arena and autonomously navigating in the testing arena. But due to these artificial lights, we have increased the threshold, but it's not detecting yet. Let us show the demonstration with manually how it is working, sir. Thank you, sir.
Shall I switch on the lights, sir? Lights. want any? Not fully off, they will not be able to see yellow inside.
It will also not red because the yellow reflection will become zero, so it will also not.
There is no light, what will reflect?
Like in the outdoor condition, the natural condition was working fine, but
No, fine. Now if you want to retain the conditions, we will retain the conditions or we will change them.
So just give us 2 minutes.
Yeah, we discuss.
क्या गैलेक्सी में चला ना 8 इंच का चला ना DFS इंस्टॉल 3 ना DFS इंस्टॉल 3 फोन चालू कर लिया फिर जाना पड़ेगा हां तो हम फिर से स्विप चलाना DFS पैचेस से ना सीधे पैचेस से डाउनलोड चलाना स्विप सीधे डाउनलोड DFS उसको क्लियर किया इसके लिए रिक्वायरमेंट्स क्या थी आर्टिनेट तो क्या था नहीं बस इनिशियल से दिखा देंगे लेकिन यहाँ ऑटोमेटिकली पूरा हो जाएगा दिखा देंगे इनिशियल से निकाल देंगे उसके बाद अपनी आगे सी इसमें आपको कौन बस कर चाहिए तो आर्टिनेट में आर्टिनेट लॉन्च कर रहा हूँ देव कुछ हेलो देव बोल ये कमरा नहीं
अरे इसलिए माताಡ್ತಾರಪ್ಪ ये पेंट ಬೇಡ
अगर बोल ये प्लीज
Jury, we are launching the nodes, so please just wait 2 minutes, then we will do the manual testing.
Amazon. Let also वो दूर चला गया छोटे पीछे नहीं चल गया आर्टिन में चलाऊंगा ट्रांसफर करना पड़ेगा
नीचे वाली के ऊपर वाली
ట్రైనింగ్ అటెండ్ అయితే అక్కడ ఇచ్చేవాళ్ళు ట్రైనింగ్ ఇస్తారు మనందరూ అబౌవ్ 18 ఇక్కడ 16 కూడా ఉన్నారు ఓకే అబ్బో ముంతగా
डायरेक्ट चला देते तो DFS 3 को पक्का
स्क्रिप्ट अंदर है नहीं स्क्रिप्ट अंदर डाउनलोड्स के अंदर है अच्छा सॉरी हिंदी कैप्चर हो गया सीडी स्क्रिप्ट करने में वेट कर लो ठीक है कैसे कम डाउन कर लगेगा फॉरवर्ड आ जाएगा मूवीज के फॉरवर्ड करना फिर क्या करता है लेफ्ट करना तो मुझे बता देना ठीक है रोशन हां वहां पहुंच गए वहां पहुंच चलेगा नहीं चलेगा चलेगा ठीक है बता देना मेरा वो के साथ ऐसे कर लैपटॉप पे हां इधर दिखाना हो ये क्या Okay, sir. Jury, now we are launching the manual controls throughout the drone, and we will scan the complete arena and show you how the navigation and the safe rotation is working properly. कर रही है डिटेक्ट नहीं कर रहा यस इट्स मैनुअल
So this was the some of the execution. The whole arena is scanned, but we will show you the visuals. And the landing was autonomous. He has toggled the switch for the autonomous navigation for the autonomous landing, and it successfully landed on the same exact spot which was commanded by the ground station. The ground station is in hands. The controller, RC controller. Right. Exactly, sir.
This is right telecommand.
This is telemetry. This is odometry for visual slam. Now we finish. Let us show them some screenshots what we have previously done. है हमारे पास? हाँ है, लैपटॉप ले लो तो ऐसा कर लैपटॉप ले लो और इसमें कुछ दिखा दो जो हमारे पास है. वो डीप सी प्रोडक्शन की वीडियो किल सारी स्क्रीनशॉट्स दिखा रहा हूँ. डिटेक्शन को इस पे चला रहा है वीडियो पे जो हमारे पुराने वाले देना पड़ता है. और से कहीं भी ना ये दिखा सकते हैं. एक देखो तो जो है तो कहाँ पर है आगे है. Sir, you would like to explain and show some of the previous results that we have already collected. Jury, we would like to show you some results, some screenshots. Like during the manual navigation, due to some connection issues, we cannot show you the continuous results because of the Wi-Fi connectivity issues. But we would like to show you some screenshots that we have created after initializing the full arena. So this is how it's working. Like this was the previous videos for safe spot detection. Like you can see in the safe spot detection, nothing is in the arena, like no objects or nothing. So it is detecting the safe spot in the whole frame, and it is also giving the data like offsets. So now we have some obstacles in our previous arena, so no safe spot detected. But as soon as we got some space, which is can be considered as a safe spot, it detected automatically, showing the centroid to align the camera frame with the safe spot frame, so that the precision landing can be done. This was also done autonomously. Now centroid and offsets, whatever be the data we will require for the safe landing, is simultaneously delivered by the algorithm throughout the visuals and with on the terminal only. So this was the whole safe spot detection approach that we have previously implemented during the previous evaluations round. Now this is the arena installation. Like we have started from one of the corner, and we have moved forward, leftward, and then right some movements. So this has also calculated all the distances from the center, like leftmost edge, rightmost edge, forward edge, and the backward edge. Then it has configured the whole arena according to its navigation and initialized it. Now it will, if autonomously it was working, then it will be doing this like this, that it will start from this particular safe spot and visits each cell one by one, and if in between a safe spot was detected, then it will detect it and launch the land command so that it can be landed successfully with the precision. For the precision purpose, we have already the safe spot detection approach that was working fine, giving the centroid of the frame and centroid of the safe spot to make the precise and accurate landing. Now if you want any questions, any queries, then we are ready for answer that. Yes, sir. Because, sir, everything from scratch to top, everything was built with our CAD designers, by our mechanical experts who have designed each and everything part. Like in this particular drone, everything is mounted. Nothing is like zip tied or like pasted or some kind of use of glue. We have mounted each and everything from sensors to battery to sensors, cameras, and everything frame. Everything is mounted perfectly so that during the navigation, nothing can be discharged from the arena that can cause casualty and harm to the drone itself. So everything is created from scratch, like landing gears, arms. The whole frame and the arms are also made up of carbon fiber to give it a strong durability and endurance, so that if it gets some impact, like during the navigation or hit some obstacles, then it will not break or not collapse during the execution task. So this was all constructed by our team individually.
All of your sensors are working, but what do you think where you missed?
Sir, we have, unfortunately, we have missed only because of the yellow border detection. Like it was navigating perfectly, it was maintaining its trajectory, detecting all the errors, deviations from the path. But as soon as it got to the boundary, it was unable to detect the boundary due to some lighting conditions. Like
you have not simulated the saturation of camera.
What, sir?
In your previous simulations, camera
Yes.
saturations you have not simulated.
Sir, we have simulated, like right now, like 10 minutes before, we are simulating the same execution outside the ground, in the testing arena. Where there it was working very perfectly, like it was giving the pinpoint accuracy. As soon as it detects the boundary, it just starts reflecting its trajectory and return back to the home position.
What I mean to say, that yellow will become white once the camera saturates. But still you have contrast to make differentiation between other.
So the approach we have used is just basically based on some of the HSB values from our range from the light bright to the dark bright, or some kind of different color combinations of yellow. So that was a particular condition that was not right now favoring our drone, our algorithm. That's why it is not successfully detecting the yellow border direction. Otherwise, it was working very fine, like in natural lighting and in outside in testing arena, it was working very well.
Okay, good.
This what I'm telling.
You are telling your structure and all is very lightweight, carbon and all.
Yes, sir.
What is the lift to weight ratio you achieved here?
Sir, what?
Lift to weight ratio.
Sir, lift to weight ratio?
Actually 2.5:1, because the motor gives 1.4 kg approx. 1.4 kg thrust approx at 100% throttle, and our whole in-app weight is approximately equal to 2 kg, and somewhere between 1.95 kg to 2 kg. So if we calculate it, it's coming around 2.5:1, which is enough for autonomous missions and for hovering and for perfect stability of the in-app.
Like we have also seen in the previous autonomous navigation, the stability of the drone was very perfect. It was maintaining its altitude and its position very accurately. It was not deviating, fluctuating like very random. So that was the reason. Because of the mass distribution and the center of mass of the drone is calibrated and designed in such a way, the components are placed in the drone and mounted on the drone in such a way that the mass distribution or the center of mass of the drone should be pinpoint accurate, so that the motor doesn't need to make some external efforts to maintain the position of the drone at the single position. Yes,
this your boundary detection, actually you have an information of boundary size. That
Yes,
means
sir.
you know the arena size. Why that input you cannot use, even though boundaries, let us say that
Sir,
side
because
is
we have designed this robust algorithm, because like if not only in the
No, I
corner,
agree.
if we placed our drone anywhere in the arena.
Yeah, what I'm telling, input is there for you, the arena size.
Yes, sir.
See, in an algorithm, that also can as an input.
Yes, sir.
See, without taking that input, if such type of failure is there, it will not able to detect the boundary itself. See, that way you lost, is it not?
Yes, sir. This was the same thing I have
No, what
explained.
I'm telling, making more generalization is a good thing.
Yes, sir.
But once information is available, it
Yes,
can
sir.
be used for limit checks or
Sir, we have already used the information, but we have designed our algorithm in such a way that if the drone is placed in any part of the arena.
I agree with that, but
Yes,
when
sir.
movement takes place,
Yes,
you
sir.
know how much distance it has moved. That
Yes, sir. We
information
have
available.
also calibrated the threshold. Like we have a threshold of 12 meter to cross 9 meters, because the arena configuration is 12 by 9 meters. So if the drone exceeds the 12 meter limit in a particular direction, it will automatically stop itself and return to the home position, because it already knows, the algorithm already knows that the maximum movement that I can done in a particular direction is 12 meter or 9 meters. So the 9 meter threshold, 12 meter threshold is given. If it exceeds that, then it will return to its home position. Like
No, what I'm telling you, when you got a second chance to operate,
Yes, sir.
those limit possible to change, and you can make a good demonstration. That's what I feel. Your is the last.
yes, sir. Sir, we have tried our best,
Employees.
but because of some problems.
Can
Yes, sir.
you,
Thank you, sir.
can you just
Yes, sir.
we will rearrange the sitting system. All.
Yes, sir. Yes, sir. Yes, sir. No, sir. Sir, we are making some precision landing. Like if during the DFS algorithm, after initializing the arena, during the DFS navigation, whenever a script finds out a safe spot, it will give, like we have demonstrated already in through the video, that through the safe spot detection, it is giving two important parameters. One is centroid of the frame, and second is centroid of the safe spot. So what the algorithm does is in such a way that it will try to overlap the centroid of the frame and centroid of the safe spot border. So in this way, after the precision calculations, it will align itself exactly above the center of the safe spot, and then it will perform landing. Not like not in a single go, like it will detect the safe spot and not lands. Yes, sir. We have. Yes, sir. Yes, sir.
Sir, can you please?
Yes, sir. So, drift is on the basis of the movements of the drone. Like we have also fused the optical flow sensors, which is in the real time, which give us the drift value, like from the original trajectory, how much the drone is drifting on which direction. It also gives the direction, height. It is a three-dimensional drifting. Exactly drift. Yes, sir. It is around plus minus 5 centimeter. Like in the plus minus 5 centimeter. If it is drifting in the negative direction, then it will also detect it. If it is drifting in the positive direction, then it will also be detected. Yes, sir. Thank you very much, sir. Unfortunately, sir, we are unable to demonstrate you, but we have worked very well. Yes, sir. Thank you very much, sir. Any other questions, sir? Okay. Thank you very much, sir. Thank you, jury.